China's nuclear doctrine. Here you can see on the map various production facilities, including the Lop-Nor nuclear weapons test site in Xinjiang province in Near the border of Mongolia. You can see Chien Tuition, which is the Chien Tuition atomic energy complex, which contributes some of the fuel, as well as Lanzhou nuclear fuel complex in Gansu province. There's the gaseous diffusion uranium enrichment plant in Heping, and you can see the various other storage sites at the different People's Liberation Army Rocket Forces Brigade areas. For further details on nuclear weapons sites, please consult the Nuclear Weapons Strategy lecture on the different methods for enriching uranium or producing plutonium. Here's a map showing the distribution of nuclear weapons. You can imagine that there's been a significant reduction in weapons since the Cold War. The U.S. manufactured a total of 71,000 warheads during the Cold War up until 1994, according to Stephen Schwartz in Atomic Audit. The Soviet Union about 55,000 in the same period, although many of these weapons, about half, were tactical nuclear weapons and therefore had much smaller yields. You can see the rise of warheads in Pakistan and India, as well as North Korea and Israel. There's a big question as to which of these warheads are actually thermonuclear as opposed to boosted fission, where boosted fission warheads could be have a yield of up to 50 kilotons. This is in comparison to a 10 to 12 kiloton warhead used at Hiroshima. The thermonuclear weapons have no upper limit, although the Thai Bomba, which was a Soviet test, had 100 megatons capability, although it was dialed down to only 52 megatons. Most warheads in the U.S. arsenal are less than a megaton, because it was found that if you have a smaller warhead, you have more efficient use of scarce material, and it's more efficient to have many small warheads well targeted than a very large warhead with weaker accuracy. And with a very large warhead, you're going to get fratricide, where a warhead detonates and damages other proximate friendly warheads coming in. So one of the big puzzles you can see here is how incredibly small China's arsenal has been historically, given the a number of foreign policy disputes that have occurred on China's borders. It could indicate that China's been very risk acceptant. It could be that Mao Zedong thought that China was invulnerable to nuclear weapons. It could be that China simply had no choice. It couldn't divert the resources towards nuclear production. So there's a variety of reasons that could explain the very small Chinese arsenal that only now is growing at some pace. Obviously, China is unique because it's got multiple countries on its borders that have nuclear weapons. Those are four: Russia, North Korea, India, and Pakistan. No other country in the world has that many nuclear neighbors. Unless, of course, you take into account NATO countries that have dual use, or rather sharing the authorization to share nuclear weapons from the U.S. China also likely does not have tactical nuclear weapons. This is important to consider because it is possible for countries to go to war and not use nuclear weapons, or to only use tactical nuclear weapons, and for fear of escalation, not escalate to the use of strategic nuclear weapons against cities. So nuclear strategy is fairly complex, and normally you'd want a full spectrum of nuclear weapon types to be able to deter at each level, something which China has not done. We begin with the nuclear history of China. Chinese communist leaders considered the utility of nuclear weapons shortly after their use in 1945, the American dropping of nuclear weapons on Hiroshima and Nagasaki. However, China's defeat of the Nationalists, a U.S. ally, and confrontation of the U.S. in the Korean War under a Soviet nuclear umbrella made China believe it could resist the threat of the use of nuclear weapons. Mao Zedong believed that China's population was so large that it could resist a nuclear attack and that nuclear weapons were a paper tiger. China's decision to proceed with a nuclear arsenal was triggered by the first Taiwan Straits crisis in 1954-55. Mao Zedong convened the Politburo on the 15th of January 1955 to initiate Weapons Development Program 02. And 2 days later, the Soviet Union announced it would assist China with peaceful nuclear research. China was initially technically very far from being able to manufacture a nuclear weapon. In a secret agreement, the New Technology for National Defense, on 15 October 1957, the Soviets agreed to provide China with a sample of a nuclear weapon and the technical information needed to manufacture it. The USSR terminated the promise in 1959 under Nikita Khrushchev, but Soviet technology transfer was already significant. When the Soviets disengaged, they had helped China train thousands of physicists and engineers, opened up mines, and shared plans for enrichment and reactor designs. The USSR also provided bombers, the H-5 and the H-6, which is a non-nuclear powered submarine that is able to launch missiles vertically. By comparison to non-nuclear aid, the Soviet Union also provided 1,800 aircraft as well as tanks, artillery, and warships. You can see on the top left the H-6 bomber. Again, it's the Badger Tupolev 16 that was designed in the 1950s and has since been upgraded. You've got the Aleutian 5, which is on the top right. Then you've got the two missiles that were indicated before, the SS-3 Shyster and the SS-4 Sandal, both intermediate range ballistic missiles. And you can see the Gulf SSB, which is used for missile tests in port. This submarine is no longer in use, although it was available for research past 2000. Moscow cut off aid under Nikita Khrushchev because China refused to closely coordinate its grand strategy with the USSR. The USSR, for example, wanted to take control of the Chinese Navy and operate the Soviet Navy off the Chinese coast in order to be able to launch ballistic missile submarines and operate its Navy against the U.S., even in the winter period when its own ports would be closed off with ice. There were other reasons as well. Out of desperation, the Soviet Union under Joseph Stalin supported the Kuomintang, which, although it was a party and a nationalist Chinese party that received assistance from the Soviets for its organization, was anti-communist and spent much of its time fighting the communist government. The Moscow's logic was that it needed to counterbalance the Japanese threat effectively, and supporting the Kuomintang, who were much better organized than the communists, was the better strategic maneuver. Ultimately, Japan's threat to the Soviet Far East caused the Soviet Union to remove their advisor to the Kuomintang, and the communists then received support at the end of the Second World War and during the Chinese Civil War. But the bad feeling between the Soviet leader, Joseph Stalin, and Mao Zedong, who, to compensate for a lack of Soviet assistance, received help from the Americans and negotiated with the Americans, showed that the relationship was not that deep, even if both countries were communist. This was worsened after the first Taiwan Straits crisis in 1954-55, when China tried to capture Taiwanese islands, and ultimately the relationship broke in 1959 in Moscow, where the Chinese communists accused the Soviet Union of being revisionists and of not essentially being afraid of confrontation with the capitalist West. After the Soviet Union did not support China during the 1958 Taiwan Straits crisis, which is a second attempt to capture Quemoy and Matsu by the Chinese off these are Taiwanese islands off the Chinese coast. So this had a huge impact on China's nuclear weapons development. The Soviets had a warhead on a train that Nikita Khrushchev organized to send to China, but ultimately sharing that technology was canceled. So the organization that supervises the nuclear weapons program is displayed here, operating through the Military Commission and various research organizations. Ni Rongzhen was the general responsible not only for the rocket forces but for its development. He'd studied in France, Belgium, and the Soviet Union. He was a participant in the 1935 Long March, which solidified him as a part of the senior leadership of the Communist Party. Nuclear weapons are under the operational command of the Central Military Commission and specifically operationally under command of PLARF, the People's Liberation Army Rocket Forces. Before 2016, they were termed the Second Artillery. China's nuclear weapons program was based heavily on foreign-educated Chinese. Most of these were immigrants or they were students studying abroad during problems in China. Many were liberalized. Many were nationalists who want to go back and strengthen China and were not necessarily communist. In fact, the majority of them were not communist. We have Wang Gangchang, who received his PhD in Berlin in 1934 and then went off to be a researcher at Dubna in the USSR in 1956. He'd returned to China in 1934 during the Japanese invasion and, of course, wanted to make China strong. Many Chinese were humiliated by the destructiveness of Japan's advance and the demonstrated weakness of China, and knew the theory of nuclear physics, even if they were not then aware of nuclear weapons. So these individuals were not educating themselves in physics for the purposes of building nuclear weapons at the beginning. It should be pointed out they could have deduced it, but we don't know that they did, from H.G. Wells' 1914 book, The World Set Free, which was the first fictional account of a nuclear war based on an extrapolation of H.G. Wells' readings of Einstein's publications before 1910 on E is equal to mc squared and the amount of energy that can be released from nuclear materials. H.G. Wells called his material a fictitious name that's not on the periodic table, and he also saw the energy release as more distributed than an instant explosion. His book is easily available for free for download from the internet, just to show that some had deduced the existence of nuclear weapons and their political effects even before the First World War had begun. But whether or not these Chinese scientists were aware of that is unknown. Chiang Kai-jia received his PhD at Edinburgh and returned to China in 1950. So this is an example of someone who's nationalist. They go back to China with knowledge of physics, awareness of nuclear weapons, which had been detonated by the Americans over Japan in 1945, and a desire to share that knowledge in order to give China the strength to stop foreign attacks and intervention. Deng Jiangshan received his PhD from Purdue, and he returned to China in 1950. He's the father of the Chinese H-bomb, or China's thermonuclear weapon. For technology on thermonuclear weapons, please look at my lecture on how nuclear weapons work, which is the Nuclear Strategy Lectures. Jiang Shenjie is PhD Columbia 1950. He returned to China in 1950 as well. All of these individuals returned in 1950, within a year of the consolidation of the communist government in Beijing. Zhu Guangjia received his PhD from Michigan, and he also returned to China in 1950. There are other diaspora Chinese scientists. All of them are born in China, but many of them not only went abroad to study, but went abroad and became professors and didn't actually have an intention to return to China necessarily. But they were, again, motivated by nationalist ideals, not intense ideals, but simply the ideal of keeping China strong enough to deter foreign intervention. There's Chien Tuition, a PhD Yale, Johns Hopkins, and he worked at Westinghouse, later the company that manufactured nuclear engines for the U.S. He returned to China in 1958. There's Guo Yonghui, Master of Science, University of Toronto in 1940, PhD Caltech 1945, Associate Professor, Cornell University 1946, and he returned to China in 1956. Pang Huanwu, PhD Edinburgh 1938, he returned to China in 1947. And Chien Tuition, he worked at the Curie Laboratory and received his PhD in Paris in 1943. He returned to China in 1948. It is possible he had learned about nuclear weapons and their possibility because the French were the first country to conceive technically of the feasibility of a nuclear weapon. And that information was passed on to the English at the time that the Germans invaded and conquered France in 1940. The French had already hidden their fissile material in caves in their colony in Morocco, never to be discovered by the Germans until after the war had ended. There's the sad story of rocket engineer Chien Tuition, a Master of Science, MIT 1936, Caltech, PhD 1939, Caltech professor, and then MIT professor. He was brought to Europe by the U.S. government to make technical assessments of the German rocket program. He was a genuine American citizen, an American strategic asset, incredibly knowledgeable, more knowledgeable than the vast majority of American rocket scientists. He was on the level of a Wernher von Braun as far as theory goes, although the U.S. didn't fund rocket programs because, of course, they had air superiority, so they could use bombers to strike enemy targets. They didn't need short-range ballistic missiles. And so he conducted intelligence assessments in Germany of the various weapons and provided a lot of the information that led to the patriation of many of the German scientists back into the U.S. To start up a U.S. missile program. Wernher von Braun, SS general, who was responsible for the V2 program, ultimately became one of the executives in NASA who helped design the rockets that put Apollo 11 and American astronauts on the moon. U.S. government became concerned that he had sympathies with China, and it's not at all clear that this was true. It is one of the great imponderables. There is no evidence he conducted any espionage or had planned to go back to China. But because of suspicions, he was arrested and he was incarcerated. And without any reason to continue his incarceration, he was eventually released in 1955 and, of course, deported to China. And so this is, in some ways, a tragedy. On the one hand, it's credible that anyone who was Chinese at the time would have been humiliated by the Japanese attack on China and just the cumulative demonstrated weakness of China, which many of these people knew. They knew the long history of China and knew how far it had fallen. So perhaps J. Edgar Hoover of the FBI was right in having him incarcerated. On the other hand, it's very, very difficult to tell. There are a great many individuals who joined the U.S. side and didn't share information outside to other countries, regardless of their ethnic identity. He became the father of China's missile program. So one of the leading rocketeers trained and worked in the U.S. as a missile professor, ultimately organized China's missile program, and is largely the reason why China developed their missile program so incredibly quickly compared to the high level investment of other countries. The Germans spent on their missile program almost as much as the Americans spent on the Manhattan Project. although both of those programs were smaller than the Anglo-American radar program. So we're talking about an enormous program with a lot of investment, and Professor Chien Tuition had access to that data after the end of the Second World War. So China's nuclear weapons development cost estimate from the 1950s to 1964 was about 28 billion US dollars, which was 37% of the state budget for 1957, and more than all defense spending between 1957 and 1958. So we can see that China made nuclear weapons a very high priority immediately after the installation of the Communist Party in Beijing. There was a clear realization that China could not be a great power and could not deter intervention by other great powers without nuclear weapons. Now, clearly, it took a very long time, much longer probably than Beijing estimated, to actually obtain nuclear weapons. But the scale of the early investment shows the level of insecurity in the Communist Party and in Mao Zedong's mind. Now, this is the cost of a slow progress program involving massive infrastructure investment. China pursued the enriched uranium route because it lacked the resources for the plutonium route. And it employed several hundred thousands of people, led by cadres of physicists and engineers trained in the Soviet Union, and of course, who had immigrated in from abroad. For differences between the enriched uranium route and the plutonium route, you can examine the discussion under nuclear strategy on nuclear weapons programs. Now, direct weapons development costs were about $1 billion. There are an additional $2.8 billion indirect costs for a total of $3.6 billion between 1955 and 1964, though the cost of annual research was about $100 million, which is 5% of the defense budget, which is pretty low. Chinese claim to have built the bomb at much lower cost than the Soviet Union. And of course, this might be true, but given the influx of Western-trained physicists, clearly there's leapfrogging. The Chinese benefited from learning how other countries were operating the bomb, and plus they received a lot of assistance in technical education from the Soviet Union. China's investment in missile technology from 1965 to 1979 was only 5% of its total defense spending. This is unusual. Normally missiles cost a lot more than warheads. Although a large warhead program is going to be very expensive, a large missile program would be more expensive. The CSS-4 or DF-5 ICBM, which became operational in 1980 or 1981 or 1982, and there were 18 of them which China built that could target most of the continental U.S. They cost merely $25 million, 10 of which would have cost less than 5% of the annual procurement in 2000. So China built a small number of ICBMs. And again, we're compared to the number of missiles built by the Soviet Union or by the U.S. or even by Nazi Germany at the end of World War II. This is a very small investment, and it's still unclear today how much of this had to do with economic limitations, how much of it had to do with intentional strategy. In other words, building a symbolic arsenal and not a large provocative arsenal. We will now examine the timeline of Chinese nuclear developments. In 1949, China purchased nuclear instruments from Europe. 1954, China begins large-scale uranium prospecting within China. 1955, Mao Zedong and the Chinese Politburo decide to proceed with Program 02. This is after the first Taiwan Straits crisis and the disappointing defeat, and the absence of Soviet nuclear threats to help China reconquer Taiwan. The USSR begins large-scale nuclear technology assistance to China shortly thereafter. In 1956, the USSR builds China a research reactor at Tuoli, just outside of Beijing. China also begins missile research and receives the R-1, which is the German V-2 from the USSR. At the end of the Second World War, whereas most of the German scientists escaped to be captured by the Americans for their safety, the Soviet Union captured Peenemünde in Poland, which was the research and testing site for the V-2 rocket, as well as some of the facilities near Harz Mountain in Germany, which contained the V-2 missile assembly site. So the Russians had a lot of examples of the V-2 and were able to reverse engineer it and provide it to their allies. Here you can see the V-2 or R-1 being tested by the Chinese. In 1958, the USSR delivered 2 R-2 IRBMs to China, and China launched its first rocket. This is a big technological jump for China, and as you can see, it took almost a decade for China to launch its first operational rocket. In 1959, the USSR, under Nikita Khrushchev, canceled the warhead transfer to China. The USSR considered China far too aggressive over the Taiwan Straits crisis, because at that time, the Soviet Union had missiles with warheads and bombers, but no missiles that could reach the continental U.S. at that time. So obviously this led to Operation Anadir, where the Soviet Union tried to put missiles in Cuba, but the implication was the USSR could certainly attack Europe or Japan, but then it was exposed to a retaliatory nuclear strike. And at that time, under U.S. President Eisenhower, Dwight D. Eisenhower, the U.S. had a policy of massive retaliation, so there's no restraint, no implied restraint in U.S. strategy. They would simply bomb the Soviet Union. And at that time, the political culture in the U.S. with regard to nuclear weapons was one of impunity. The Americans were effectively, with the exception of a few Soviet submarines that could launch missiles off the U.S. coast, that the Americans were fairly confident they could sweep up in an anti-submarine warfare sensor sweep up and down the coast of the Atlantic. The Soviet Union was completely exposed to U.S. retaliation. China built its first H-6, which is the Tupolev 16 Badger bomber aircraft, that is still in use today and has been upgraded as both a bomber, a maritime reconnaissance aircraft, and as a tanker. 1960, China launches the indigenously built R-2 rocket. Here you can see China working on its rocket parallel to its warhead program, and in fact it's doing more progress on rockets than on the warhead, which is actually counter to the experience of countries like the Soviet Union, even the U.S. and India. India detonated its first warhead in 1974, although it was not a nuclear warhead. It was an engineering project warhead, a peaceful nuclear explosive, a PNE. And it discovered developing a reliable missile took a great time longer. And ultimately, India did not detonate its nuclear warhead until 1998, once it had a missile that could operate at least a short distance. So China here was ahead, unusually ahead, with its rocket program. 1963, China begins its hexafluoride production at the Jiuquan complex. This is important. Hexafluoride takes uranium, which has been extracted from ore, and allows you to turn into a gaseous state, which allows you to put it through one of the 7 processes for enrichment. What enrichment means is you want to separate the uranium-238, which is used for other purposes, from the lighter uranium-235, which is the fissile material used for warheads. So there are 7 different processes, and if you consult my nuclear weapons lecture on nuclear weapons production, I cover the 7 different methods. But the method China was using was gaseous diffusion, where you force the hexafluoride through a semi-permeable membrane, in which the lighter element is more likely to be pushed through the small holes, and the heavier element is discarded or moved on to the next selection level. So you have what is called a cascade, or a huge facility with these tanks, each with its own semi-permeable membrane. And you would pass this gas through this large, what looks like a chandelier complex of connected tanks with the semi-permeable sheets in them. You would push it through several thousand times in order to increase the purity until you get pure uranium-235. So it took China, in fact, quite a long time to develop this capacity, almost a decade after they decided to initiate weapons program 002 following the poor results from the first Taiwan Straits crisis in 1954. So in 1964, highly enriched uranium is produced at the Lanzhou gaseous diffusion plant, and nuclear bomb components are assembled at the Jiuquan complex. And an H-6 bomber that was shown earlier, the Tupolev 16 Badger, acquired from the Soviet Union in the 1950s, was retrofitted to drop nuclear weapons. Lithium was produced also for thermonuclear weapons, although they were not tested at that time. And on October 16th, China assembled the bomb, put it aboard the H-6, and dropped the 22 kiloton fission device at Lop Nor in the desert in Xinjiang. This was China's first atomic bomb test. The 22 kiloton device is comparable in power to the 12 kiloton device dropped on Hiroshima, and the almost 20 kiloton device dropped by the US at Nagasaki in 1945. In 1965, China dropped a 40 kiloton fission atomic bomb from an H-6 bomber. China also assembled the Gulf-class SSB, which was used for as a ballistic missile submarine test bed. So you can see China started this test very early on. Germany had also, during the last few years of the Nazi regime, considered similar tests. So this is not a dramatic idea. It's a logical deduction to hide nuclear weapons underwater in submarines, and to transport short-range submarines off the coast of countries like the U.S. The problem was the engineering, and it took decades before China was able to deploy an operational submarine that could actually do this. In fact, it took 3 decades, more than a generation, to evolve the technology. You can see here Chinese Marshal Chen Yi emphasizing that China would not share nuclear weapons technology with other countries. This is an early assertion done immediately after the year after the atomic bomb test in 1964. Now, a major delay in the development of nuclear weapons was the Cultural Revolution. 1965 to 1975, Mao Zedong mobilized the youth of China. There was a population boom and a lot of young Chinese. And Mao was trying to neutralize the competition in the Communist Party and the Politburo of those Chinese leaders that were hostile to his cult of personality. And because they blamed Mao Zedong for the Great Leap Forward, 1958 to 1961, which killed several tens of millions of Chinese. And so in this way, he was able to neutralize the leadership. Now, it didn't seem to slow down research. So it seemed that the military and the scientists operating in the military areas were isolated from the chaos, but it had a huge effect on production, engineering, and manufacturing, which meant it delayed the mass production of a lot of these weapons, and it's one of the reasons why it took so long to develop the program. Alternately, one can interpret the Cultural Revolution as the imposition of central control on the urban population, and so the absence of the Cultural Revolution would not have led to the mechanization and the modernization of the population as industrial workers. And so in the long term, the Cultural Revolution might have created the modern technological China we see today by destroying norms of restraint and of traditional Chinese culture. But in the short term, it had a large disruptive effect on developing China's nuclear arsenal. In 1966, China conducted its third nuclear test from an H-6 bomber with Lithium-6 for a 200 kiloton detonation. The issue with Lithium-6 is by using it in a nuclear warhead, you're able to artificially create H2 and H3, which is deuterium and tritium. It's basically the hydrogen atom, which normally has no neutron, having 1 and 2 neutrons. And under intense heat, like the center of the sun, which approximates a thermonuclear weapon, you're able to fuse that element and create enormous releases of energy on an order of magnitude much greater than you would with a normal atomic bomb using uranium-235 or plutonium-239. So this is what we would call a boosted fission weapon. So it increased the detonation from normally what you would get 20 kilotons up to 200 kilotons. China conducted its fourth test, and this time they had a 20 kiloton warhead detonated after firing a DF-2, a Dongfeng 2 missile at a range of 800 kilometers. China completed the construction of its first plutonium production reactor. Again, if you want to understand the difference between plutonium and uranium, you can look ahead to my nuclear strategy lecture on nuclear weapons warheads production. Plutonium-239 is artificially manufactured in a reactor, and it consists of firing neutrons at uranium-235, and you end up with a transmutation. The uranium-235 becomes another element, and then it decays through 2 processes, and then becomes plutonium-239. The advantage of plutonium-239 is that it generates a much bigger blast for its weight. The negative problem with plutonium-239 is that when you design the bomb, the parts have to be kept separate because plutonium-239 generates a lot of impurities that could lead to a spontaneous detonation. Whereas uranium-235 is much more robust and much more predictable and reliable in terms of when it releases neutrons to start a chain reaction. But if you want to have a small warhead on a missile, and you don't have a large bomber to carry a very large bomb, then you need to have plutonium warheads. The vast majority of U.S. missile warheads are plutonium. China test launched its DF-3 missile. It conducted a 300 kiloton formally boosted fission test. This is its 5th test overall, and this is sort of a pre-thermonuclear warhead. And obviously this involved the use of lithium, but it was not a complete thermonuclear warhead. In 1967, China's 6th test, they develop a hydrogen bomb. Now, a hydrogen bomb is a thermonuclear weapon. It has 3 stages. The first stage is a normal fission device, an atomic bomb, essentially a plutonium-239 or uranium-235. You create intense heat like the center of the sun. And what you're doing is you're splitting an atom. You're throwing neutrons at it. When an atom has too many neutrons, it'll fall apart. In the falling apart, or the fission, the breaking up of the uranium-235 atom, you have a lot of energy released and additional neutrons that then go around and hit other nuclei of atoms and causes the explosions to spread. Now, for a fusion weapon, once you've got this intense heat, like the center of the sun, you're able to take hydrogen atoms and push them together. Normally, you can't push hydrogen atoms. Most of the universe is made up of hydrogen. It's the lightest element on the periodic table. In its most common form, there are no neutrons. If you add 1 neutron, it becomes deuterium. You add 2 neutrons, it becomes tritium. Deuterium and tritium are manufactured in reactors because they're useful as a coolant. And we also use them in nuclear weapons as a fuel, although we use lithium-6 in place of the tritium and deuterium as a fuel. So in the second stage, you have a container of lithium-6. And under intense heat, it decays down into deuterium and tritium, and then you get the release of enormous amounts of energy, far in excess of what you would get with a fission bomb or a boosted fission weapon. So this hydrogen bomb test, the reason it's an interesting issue is the U.S. scientists made miscalculations, and which delayed the hydrogen project. Although the U.S. was the first to develop the hydrogen bomb, which ultimately was detonated in 1954, the delay was over a misunderstanding and miscalculation of some of the physics. Simultaneously, the FBI had begun operations to weed out the espionage network in the U.S. that was taking nuclear weapons secrets from the Manhattan Project and other projects and bringing back to the Soviet Union. So the Rosenbergs, for example, were arrested and executed. The positive impact of that is that it compelled the Soviets, under scientists like Andrei Sakharov, to focus on how to come up with the math on their own. And so the Soviet Union actually avoided some of the miscalculations in developing a thermonuclear weapon that allowed them to detonate their weapon shortly after the U.S. Detonated their weapon. So China had a similar advantage problem as the Soviet Union, which is it had to figure out how to do it on its own, and clearly their math was very good because they were able to detonate a thermonuclear weapon. Was a 3 megaton device, and this put China as one of the 6 countries that's been able to develop fusion weapons. At this point in 2023, India, Pakistan, and North Korea have not demonstrated the ability. There was a test in Prince Edward Island, south of South Africa, which is almost certainly an Israeli test, but it seems that test was a fission test, not a fusion test. But the Israelis did steal Crichtons from the U.S., so it's very likely they have manufactured thermonuclear weapons, although it's more likely that the vast majority of their weapons are boosted fission devices. China conducted a 7th test in 1967. In 1968, they had their first plutonium-based thermonuclear bomb, which was dropped from an H-6. 1969, China conducted its 10th test. And it was in that year that China and the Soviet Union had a border war, although border disputes had been accumulating since 1965. And so the Chinese ambushed a Soviet patrol outside of Khabarovsk in the Soviet Far East, and there was an escalation all along the border. And in what is today Kazakhstan, at that time the Kazakhstan Soviet Socialist Republic, the Soviets retaliated with artillery strikes. Casualties were probably several thousand on the Chinese side. It was thought that the border conflict was triggered by the Cultural Revolution. In other words, the Chinese military had become somewhat aggressive. Now, the implication of the border conflict was that you had here 2 countries with nuclear weapons. Now, the Soviet Union had a comprehensive full-spectrum nuclear arsenal. China only had a few nuclear warheads and certainly couldn't have a huge impact. But even one nuclear weapon detonated in the Soviet Union would have had a huge political impact. So the Soviet Union approached the U.S. about a disarming nuclear strike on China. They basically said, hey, listen, can we fire something at China? What would be your reaction? The U.S., of course, indicated they would refuse to cooperate with a Soviet attack on China, in part because the U.S. benefited from the Sino-Soviet border conflict. The U.S. had correctly anticipated that Russian-Chinese antipathy going back to the Chinese invasion, to the Japanese invasion of China, would eventually lead, at first Mao Zedong and Joseph Stalin, and later on Chinese and Soviet leaders to split apart. And it was one of the predictions of balance of power theory, which is 2 powerful countries that border each other will inevitably become enemies, regardless, even if they have common ideology. Now, this had implications for the stability-instability paradox, which is the idea that when you've got 2 nuclear-armed states, the 2 nuclear arsenals, no matter how big they are, will neutralize each other and thereby make war safer at the lower level. And so we have the Soviet Union stuck fighting a conventional border conflict with China and not able to use nuclear weapons, even though it had a very large arsenal. Of course, there might have been other reasons why the USSR did not attack China with nuclear weapons. In 1970, China conducted its 11th test. There was a DF-4 launch. Also, China launched its first satellite. So you can see it's a fairly rapid development of technology in China. You had not large production facilities, but you had an elite core of Western and Soviet-trained nuclear and missile scientists that could achieve many of the same technological breakthroughs at the same pace as were occurring in France and England at the time. China conducted a 12th test in 1971, a 13th and 14th test in 1972. All of these tests were atmospheric, and so the fallout was easily detected in North America and Europe, because you'd have the prevailing winds picking up the various fallout elements and putting into the high atmosphere. 1973 of the 15th test, 1974 the 16th test. 1974, China detonated its own peaceful nuclear explosive. And of course this woke China up that they were not alone and that there are other countries that were capable of catching up as well. Of course, in the Indian case, you have a very similar profile to China, which is Western-trained, particularly English-trained physicists, and Germany had invested heavily into engineering institutes in India, and so there was the engineering source of technology as well available to India. 1975, China conducts its 17th test. 1976, we have the 18th to the 21st tests. China's bomber fleet of H-6 bombers, the F-16 Badgers, reaches 64 aircraft. China's producing those aircraft. These aircraft don't have long range and they don't have refueling, but they would have been sufficient to fly into the Soviet Union. Whether they could penetrate the very powerful Soviet air defense system, not only ground-based missiles, but interceptors. The Soviet Union had an air force, and it had a separate air defense air force as well, the PVO. And it's very unlikely the Chinese bombers would have been able to make it through. In 1976, China begins formal nuclear weapons technology transfers to Pakistan. And so a lot of this starts on a very low level. It has to do with just training, not actual warheads being delivered. And it's very similar to the assistance the Soviet Union provided to China. Now, of course, the Chinese logic is they need India to be distracted. And the 1965 and 1971 wars between Pakistan and India showed that India could be quite easily distracted by Pakistan, even though Pakistan was only 1/7 of the size of India. 1977, China undergoes its 22nd test, 1978 its 23rd test, 1979 its 26th test. Here you can see Mao Zedong meeting Zulfikar Ali Bhutto, who was the leader of Pakistan from 1971-72 until his arrest and then execution shortly after in 1977. That's China's first satellite, basically a model on Sputnik. China conducted its 27th test in 1980. China launched a 10,000-kilometer range DF-5, Dongfeng 5 ICBM intercontinental ballistic missile into the Pacific Ocean. So this ICBM had the ability to hit the U.S. The previous missiles that China built were largely aimed at the Soviet Union. But China didn't have anything that could reach the U.S. Now, this is paradoxical because China and the U.S. had improved their relations significantly in 1971. Now, the relationship was hurt in 1979 because the U.S. Was partial to Taiwan, and the U.S. legislature required that the U.S. government provide Taiwan the weapons it needed to protect itself. The U.S. goal was to encourage China to confront the Soviet Union, which was successful. 1/3 of the Soviet military was redeployed to the Far East, particularly tank forces, air forces. The Soviet Union took China's threat seriously. But China and the U.S. were not closely allied. The U.S. was doing the bare minimum to get China not to focus on it. Now this is fairly common. The Indians themselves were developing an ICBM, and they arbitrarily took Washington as the target for the Surya ICBM. U.S. intelligence detected the project and advised the Indian government to cancel it because they were nominally commercial allies, and India did cancel it. And so you do have, in some ways, benchmarks of targets that are set arbitrarily. But in the case of both India and China, they targeted the largest economic power in the system. For China, it was a real problem because China had fought the U.S. in Korea in 1950 to 1953, and the U.S. had assisted the Taiwanese in 54, 55, and 58. China had, of course, in 62 fought India in a border war, and then 69 fought the Soviet Union in a border war. So China had terrestrial concerns, and the DF-5 could just as easily have been fired on Moscow. But this was simply China remembering not to exclude the U.S. so it would not be bullied, and more importantly, not be forgotten. I mean, these rockets, again, there were 18 of them. They would have caused a fraction of the damage on the U.S. that the U.S. would have reinflicted on China. China, by this time, had manufactured 100 H-6 bombers. So you can see the production rate is actually quite slow. So these are, this is certainly not a large force compared with the number of bombers that were available to, for example, the Soviet Union. In 1981, China decides to cut back on military developments in order to favor the economy. And China launches its first ballistic missile submarine, which is the Xia. So this was obviously developed off of a project to do with the Gulf. Now, it's never thought that the Xia ballistic missile submarine became operational. It was basically a very loud disappointment. It was deployed. Now, the logic for China was the missiles that it did have were on a tarmac. They were mostly liquid fueled, so it took about 2 hours to refill. It took 45 minutes for a rocket to go from the U.S. over the pole into China. And the U.S. had China under satellite surveillance, which means any attempt by China to prepare nuclear weapons for launch could have resulted in a U.S. preemptive attack and destruction of those assets. So China had no second strike capability, and this ballistic missile submarine theoretically made it possible. But this is one of the systems that became delayed because of the Cultural Revolution. It should have been deployed a decade earlier in numbers, but ultimately never became operational. And it wasn't until after the 2000s that China had operationally deployed ballistic missile submarines. So we're talking generations later. So you can see the U.S. has the Ohio system, the Russians have the Delta IV, the British Vanguard, the French Triomphant. China now has the Jin class, and India has the Arahant. The Jin class is an operational system. In 1982, China conducted its 28th test. There was the first test of the J-1 sea-launched ballistic missile from a Gulf SSB. And this was intended for the Xia class. It is speculated that China built a second Xia class in 1982. In 1983, China conducted its 29th and its 30th nuclear test. It's thought in that year that China provided Pakistan nuclear warhead blueprints. It was largely in response to India conducting many nuclear a lot of weapons research. India could have developed nuclear warheads earlier, but it's unique among governments in the world to have gone ahead with a program and to have canceled it 3 times following 3 changes of government. But India certainly had the technical capability of it, and China realized that Pakistan was falling behind. 1984, China conducts its 31st and 32nd test. China's second artillery began 24-hour alert readiness. In other words, it was ready if it was hit by nuclear weapons to retaliate, although that would have been primarily against the Soviet Union. There's little prospect of it being able to do a retaliation against the U.S. China joined the International Atomic Energy Agency. This is a part of China's plan to join international organizations in order to encourage technology exchange with China, which is a broader economic developmental goal. China has 4 DF-5 ICBMs capable of reaching the U.S. at the time. It has 125 IRBMs capable of reaching Russia, India, Japan, and Hawaii, and 40 to 60 short-range rockets for Korea, Taiwan, Vietnam, and Okinawa. So ultimately, it would have 18 DF-5s, but in 1984, it only had 4 that were available, that had been built at the time and deployed for that use. 1985, there was a failed JL-1 sea-launched ballistic missile launch from the Xia ballistic missile submarine. China assured the U.S. it would not deploy weapons outside of China. Right, this is a concern for the U.S. It was one of the reasons we have the Cuban Missile Crisis in October of 1962. Obviously, there was an implied quid pro quo. The Japanese did not welcome U.S. nuclear weapons in that country, but the U.S. had submarines and aircraft carriers with nuclear weapons that would routinely deploy in the ports of countries nearby. And the U.S. had, at some point, deployed nuclear weapons in Taiwan in the 1950s and 60s, as well as deployed over 10,000 U.S. soldiers there. 1986, China declares no more nuclear testing as a part of an international attempt to reduce the obvious health consequences. 1987, China conducts its 33rd test. In 1987, China sells 20 DF-3 rockets to Saudi Arabia. Now, the retrospective evidence is overwhelmingly that China did this for cash, not for any alliance strategy. At the time, China did not depend on Saudi Arabian oil. It was thought that the Saudis had an informal arrangement with Pakistan because they'd footed the bill for the development of Pakistan's nuclear warheads. However, over time, it looks like Pakistan and Saudi Arabia have had disputes on various strategic issues, where Saudi Arabia is currently caught in a tough rivalry with Iran. Pakistan is improving relations with Iran, partially on behalf of China, but also because of its need to acquire cheap oil. And of course, Pakistan, about 15 to 20% of its population are Shia, who are sympathetic with Iran, and improving relations with Iran would help resolve many of the Sunni Shia sectarian violence issues within Pakistan. In 1988, there was a successful JL-1C launched ballistic missile test launch from the Zia ballistic missile submarine. In 1989, we have China's 34th test of what is thought to be a neutron bomb. A neutron bomb is an ERRB, an enhanced radiation bomb, and the way it works is it's a thermonuclear weapon where the first stage is a fission device. The second stage is the tritium and deuterium created from lithium-6. But unlike a formal thermonuclear weapon, which has a uranium-238 shield, which releases an enormous amount of energy, because here you've got fast instead of slow neutrons that are being ejected from the second stage, you don't have that. So, because you don't have the outer uranium-238 shielding, you have an enormous number of neutrons. Now, the thing about neutrons is they penetrate very deeply. They'll go through very large amounts of lead, and they don't persist. They don't create fallout that you would have from a much larger thermonuclear weapon with the outer uranium-238 shield. So you have a huge amount of radiation released with much lower fallout. So you're able to destroy troops on the battlefield that are in tanks that are shielded. Now, there's no evidence that China ever manufactured neutron bombs after this, because it didn't have the same problem as the Americans and the French did, who did develop tactical nuclear weapons of a neutron bomb nature, because they needed to be able to maneuver in tight terrain and to be able to destroy large numbers of radiation-protected Soviet troops and tanks and armored personnel carriers. A neutron bomb would have solved that problem. For China, the most likely source of attack would have been Soviet armor coming out of the Far East, north of Beijing, or forces advancing into Heilongjiang and Jilin. And there's enough low hills and valleys for the Chinese to rely on a people's war to stop that type of attack. 1990, China conducts its 35th and its 36th test. Pakistan may have participated at China's nuclear tests at Lop Nor. China has about 18 to 25 DF ICBMs at that time. We know now it's approximately 18, but that was the estimate at the time. So it took about 10 years for the Chinese to build a dozen more ICBMs to target the U.S. This is approximately the time that China built its OTH, its over-the-horizon backscatter radar along the south coast, which would have allowed it to see over the horizon and to distinguish missiles launched by submarines coming at China against the background clutter of the ocean. I'm not sure what the purpose of this would have been, except to detect incoming bombers, because U.S. submarines would have been far into the Pacific launching their missiles. So China's got about 10 DF-5 ICBMs capable of reaching the U.S. at this time, and it's thought that the rest of these missiles were either not deployed for that purpose or they're deployed at the Soviet Union. In 1991, China signs the Missile Technology Control Regime, and this was important. It limited the missiles and the size of the warhead that missiles could carry that would be sent to other countries, because the U.S. was concerned about missile proliferation, and where China was not sincere, the purpose, again, was to allow China to interact commercially on high technology, like missile products, with other countries. China conducted its 37th and its 38th test in 1992. In 1992, it signs the Non-Proliferation Treaty, which is a promise not to spread nuclear weapons. It doesn't seem to have been abiding by this treaty since, because it's been building various reactors for Pakistan that seem to be dedicated to producing the fissile material for Pakistani warheads. The Non-Proliferation Treaty in 1968 was originally conceived of by the Irish diplomats, but the Americans and Russians adopted it as a part of a quid pro quo, where the Americans would not give or not allow West Germany to have nuclear weapons, and in exchange the Soviets promised not to share nuclear weapons with other countries. And so the arrangement with China was more informal, where China in the 1990s and early 2000s promised not to spread nuclear weapons technology beyond Pakistan to countries like Iran. And then the U.S. would restrain countries like Japan from developing nuclear weapons. But India and Pakistan were not affected by the treaty. So the U.S. could provide assistance to India and China, to Pakistan, and that was the informal arrangement that they came to. Now, China retaliated to the U.S. F-16 sales to Taiwan by selling M11 missiles and factory missile production facilities to Pakistan. And it also acquired a Russian Sukhoi 27 aircraft in China. The M11 forms the basis for Pakistan's indigenous missile capability. So this was China showing the strategic consequences of supporting Taiwan. 1993, China conducts its 39th test. In 1993, the U.S. and China begin non-proliferation dialogue over Iran and Pakistan. 1994, we have the 40th and the 41st tests. In 1995, the 42nd and the 43rd tests. And in 1996, the 44th and the last and 45th test. And China stops testing its nuclear weapons. In 1998, India and Pakistan conduct their nuclear tests. India first, then Pakistan responds shortly thereafter. And China does not detonate any nuclear weapons so as not to provoke India and to ensure that India's focus is on Pakistan. In 1999, China finally has 18 DF-5 ICBMs capable of reaching the U.S. because of their deployment. China completes the testing of its DF-31 intercontinental ballistic missile. This is the first Chinese missile system with solid fuel and being road mobile. Now, because it's solid fuel, it no longer takes 45 minutes to an hour to fuel up the rockets with very toxic liquid propellant, which then has to be removed and the rocket has to be cleaned because it's highly corrosive. With a road mobile system, you press a button and it launches almost immediately. So China is no longer afraid of being preempted. And the system was potentially road mobile, which meant it could be put on highways and driven around and hidden, and therefore providing some limited second strike. Now, there's a bit of a debate as to what extent mobile systems actually are providing second strike. There has never been an aerial interception of a missile launch. Even during the 1991 U.S. conflict against Iraq and the 20% of the U.S. Air Force that was deployed to chasing missiles being fired, Scud missiles being fired at Saudi Arabia and Israel, not a single missile was intercepted prior or at the moment of launch. It's very, very easy to hide mobile missiles. There was a close call where a Royal Air Force aircraft during the Second World War almost intercepted a V-2 launch from a football field in Rotterdam. And when I mean football, of course, I mean soccer. And the British just missed the collection of German vehicles that were launching the rocket. The V2 was launched from mobile platforms in Western Europe when they were targeting England and the Belgian port of Antwerp. So whether U.S. Nuclear weapons can catch these systems is a question. But the Nature Resource Defense Council has put publications online that show how vulnerable the Russian mobile systems are today by showing, in fact, once you have a vehicle on a road and not in a gully, not protected in a cement revetment, they can be destroyed or at least severely damaged to the point of inoperability from a great distance from a nuclear airburst. So there's a debate going on, and certainly further research is required. This is the DF-31, 31A ICBM launch unit in Qinghai in central China. This is obviously the non-mobile version. In 2000, Japan completed the Shimura plutonium reprocessing plant, which gave it the third largest capability for separating the 50 to 80 tons of plutonium, much of it owned by Euratom that was in its possession. And there's a big debate as to whether this material, fissile material, could be used to manufacture 1,000 warheads for Japan if ever the decision was made to proceed. It is a very important proliferation issue because the U.S. administration, under the administration of U.S. President Ronald Reagan, allowed Japan to proceed with this without sanctions. So the U.S. wanted Japan to have the technological ability to essentially develop an independent nuclear energy program, but also to have access to the type of technology that would allow it to build nuclear weapons. The U.S. legally is not allowed to sell breeder reactor technology. Breeder reactors are dedicated reactors for producing plutonium. They're powerful energy reactors. They can be as well, but they're the surest, most efficient way of manufacturing plutonium. So clearly that was either a strategic calculation or an economic calculation that was done because the U.S. is desperate to have Japan as an ally. And that's not really, the second is not really that believable of a motive. Although China's never identified Japan as a major nuclear security threat, it must certainly be noticed that Japan has this capability. And Japan, of course, is also invested in missile projects, and Japan's received assistance from the U.S. on solid fuel rockets. And Japan also moved its missile test platform from Kyushu Island, which is close to China, to the other side of Japan, which indicated some security component to Japan's missile project. In 2004, China finally launched its Jin-class ballistic missile submarine, the first of 8 of these submarines. Although at the time it was not launched operationally, these were deployed on the Chinese coast or in the South China Sea, equipped with missiles that could not reach the continental U.S. but could hit Guam, Hawaii, and parts of Alaska. You can also see the DH-10 land and air-based cruise supersonic missile, which achieved enormous speed, and these would be deployed off of the coast and off of, in particular, the H-6 bombers. Here's the DH-10 cruise missile, and you can see its range out from China. It's the yellow hashed area, which would encompass all of the Philippines, Taiwan, all of Japan, all the way to the Strait of Malacca, Singapore, and it would cover all of Pakistan if launched from within China. The purpose of the system was essentially to deter U.S. naval support to Taiwan and to the South China Sea. So as a part of China's denial project, and this cruise missile could be equipped with a nuclear warhead. In 2004, China joins the Nuclear Suppliers Group. Again, this is by joining this organization, China would then be permitted to get access to certain levels of technology, and it was a part of China's general attempt to show that it was a responsible international player, and then to get reciprocal access to technology. The alternative would have been not to join and then to be locked out of access to certain types of technology. There was an issue because India and Pakistan had not joined the nuclear suppliers group, and so there were restrictions on what kind of technology could be shared with them. But the US and China came to a de facto agreement not to apply the nuclear suppliers group limitations to either of their transactions with Pakistan and India. China developed in that year the FT-2000A, which is a development of their HQ-9 surface-to-air missile system, which is basically a copy of the Russian S-300 air defense system. And this is an endo-atmospheric ballistic missile defense system. In other words, it was designed to shoot down incoming missiles within the atmosphere. Now, the Soviet Union had this capacity in the form of the SA-10 in the 1960s and 1970s. So it's a very, very old technology, and China finally caught up in this niche area. In 2005, China began large-scale reactor constructions in Pakistan at both Chasma and Kushab, in part to provide Pakistan energy independence, but also to give it the technology it needed to independently manufacture the plutonium warheads that it otherwise would not be able to. One of the advantages of the plutonium process through a breeder reactor is that you need less overall uranium, because instead of discarding the uranium-238, you can then use it to create the plutonium-239. So normally you would rescue less than 1% of the uranium as uranium-235, and the rest of the uranium-238 would be used for other purposes. But with the plutonium system, you could use all of the uranium. You'd have a small amount of uranium-235, and the rest of it would be turned into plutonium-239, which is a very cost-effective way of using a scarce material. In 2006, China adopts the Active Defense Nuclear Doctrine, which essentially meant that it was ready to retaliate against external threats. And it was basically a declaratory policy, not an operational policy. In other words, it declared it was ready to respond to an attack just like any other country, and it would use nuclear weapons to defend itself. China launched its second Jin-class ballistic missile submarine. The U.S. and India conclude the 123 Agreement nuclear supply agreement, which caused a bit of political furor in China. What the U.S. noticed was that India's manufacturing of fissile material for their warheads was not being done very efficiently. And in fact, there wasn't enough in India. So the U.S. agreed to provide uranium for India's reactor program, and India's reactor program was actually farther along as far as energy production went than China's. The Indians had more experience with reactors. So the US would provide the uranium for India's civilian energy program, and this would free up Indian uranium to be diverted into their weapons program. And so this is what China objected to, and the US largely implemented this, one, because they needed India to counterbalance China, and two, as retaliation for Chinese assistance in Pakistan in the form of the Kushab and the Chasma reactors. China fired a ground-based targeting laser at a US satellite. This is obviously not for destruction, but it's sort of a very powerful rangefinder. The Soviets had done the same type of laser targeting of a U.S. space shuttle in the 1980s, and the U.S. had a similar system, test systems, along with the Soviets in the 1960s and 1970s. North Korea tested its first nuclear weapon in 2005. In 2007, we have China's first anti-satellite test. On January 11th, 2007, China destroyed an 850-kilometer low Earth orbit space satellite, moving at 7.42 kilometers a second, with a ground-based hit-to-kill two-stage solid-fueled ASAT. And this had obviously aside from creating a pile of orbital garbage, which made the U.S. rather upset and other countries as well, it showed that China had mastered the microchip technology for hyper-fast targeting. And so China could, instead of using a nuclear warhead as an interceptor, which is what the Soviet Union was doing even today for its ground-based interceptors around Moscow, China could use a non-nuclear warhead. And this is important because once a nuclear warhead goes off, it affects the electromagnetic spectrum, and most radars would cease to operate. They won't be able to target incoming missiles. So with hit-to-kill technology, you're not disrupting the electromagnetic spectrum, and you can repeatedly hit incoming systems. China launched its third ballistic missile submarine in that year. Now, we've lost track as to when precisely China deployed the other Jin-class ballistic missiles, but they would occur sometime after 2007 and sometime before 2020. But as you'll see later, 6 of these ballistic missile submarines would appear by 2021, indicating that China was doing a pretty efficient job of manufacturing and then deploying them without being observed. This is the missile that was launched to conduct the satellite interception. In 2008, India deploys its Agni intermediate range ballistic missile, which essentially could reach any target within China. So at this point, India could target China, although even in 2023, India has not created a large-scale deployment of this missile. But China could now be targeted by China with a small arsenal from a third party, not only the USSR, Russia, or the US. In 2008, China also revealed extensive underground tunnel systems for regime survivability. So there were thought to be up to 300 kilometers of tunnel systems all across China. These were first discovered, and then later China demonstrated this. Now, this seems to be consistent with the Soviet Union, where regime survival is paramount, because the philosophy of authoritarian regimes is that the population they're leading are troublesome, and there are many counter-revolutionary elements, and so the priority should be the survival of the regime, since they can guide the people. And so the U.S. responded to the assumption that the regime prioritized its survival by targeting the military that would be providing security to the regime, as well as developing systems that could break through the ground into the bunkers and destroy those complexes. And this did seem to have a positive effect for the Americans on the Soviet Union. The Soviet Union became incredibly insecure. Where the U.S. has faith that the civil authorities will persist even during a nuclear war, the Soviet Union and communist China have a very pessimistic view of the reliability of their populations. And so they build these very large complexes for their regime to survive. The U.S. does have similar underground facilities, but not on the same scale. The U.S. prefers to put its assets airborne or at sea. So dispersal is their solution. And there are underground complexes for storing bank information and for the U.S. legislature, but it's not because the U.S. government is afraid of the U.S. population. There simply aren't enough resources to protect the U.S. population. In 2009, China deploys its first 15 DF-31 road mobile ICBMs with MIRVs. A MIRV is an independently targeted reentry vehicle. It's basically a bus. When the rocket goes into space, the top of the rocket comes off, and you have this flat platform, and it contains a number of warheads. It could be up to 5 or 10. And then some of those are decoys. They're just inflatables, or they're various electronic transmitting devices meant to interfere with interceptors. But, up to half could be the actual warheads. And the bus will change direction. Now, a ballistic missile, when it means ballistic, it means it follows a path governed by physics. But this bus has some ability to re-aim, so it'll send the rockets off in different directions to redeploy. And then aimed at various military targets or cities or what have you. When I was in Cheyenne Mountain in 2002, which is NORAD headquarters, we watched a simulation in one of the command centers, and essentially, when the rocket takes off, the Americans have satellites into space that identify the hot plume coming out of the back of the rocket, so they're easy to identify when they get into space. Once they're into space, they're very difficult to detect. And in fact, because of the physics of space, it's difficult to tell the difference between a really heavy warhead and an inflatable that looks the same. So, although there are developing technologies that are able to bounce lasers off and check the texture of whatever it is that they're looking at. And then these are redetected visually or by radar as they come back into the atmosphere. So there's a period when it's not sure where they're going to go. As they come in, there's a probability estimate as to where they're going to land, which is normally represented by an oval that quickly is shrinking and contracting as it's possible to estimate exactly where the warhead's going to land. And all of this helps intercept the missile if there's a plan to intercept it or to avoid it if you're launching bombers. Now, NORAD headquarters, which is a joint Canadian-American command, is deployed in Colorado near Peterson Air Force Base. There's an alternate command center that uses the same inputs from satellites and from ground surveillance called DEFSMAC, which is deployed in Maryland. And that intelligence organization feeds the information to the Pentagon, which helps command the missiles for war, as well as Strategic Air Command, which enables them to plan their missile counterattack. So there's actually sort of a redundant system. So these are only 15 systems. Again, they're solid fuel, so that they're launched faster than liquid fueled, and they could be launched immediately, which means it's impossible for the U.S. to preempt them. Even if they detect their deployment somewhere with a satellite, these things launch when you press the button. And these things can reach most of the continental U.S., but not all of it. Now, in that year, India launches its first spy satellite, the RESAT-1, which is important because spy satellites are used for monitoring the deployment of missile systems, and especially mobile missile systems. So essentially, China fell under the close observation of a neighboring country other than the Soviet Union. India also launched its Arahant ballistic missile submarine. This is not a submarine that could reach deeply into China, but it indicated to China that India was in the business of manufacturing ballistic missile submarines. And the vastness of the Indian Ocean meant that China had almost no prospect of interfering with that kind of second strike capability in India. It was estimated in that year that China had up to 5,000 kilometers of underground facilities that would be essentially usable to hide its various military assets, particularly its air units. In 2009, North Korea conducted its second nuclear test. Again, this has a big impact on China's diplomacy. In 2010, China's ballistic missile defense system successfully intercepted a missile in mid-course. Now, what this means is that you have a missile taking off. It's got a lot of fire coming out of the back as it's pushing up in the atmosphere. It's moving very slowly. It's easily identified. And then when it goes into space, it's harder to detect. Only when it's coming back in can be picked up again by radar. So the fact that it was intercepted mid-course, exoatmospherically, outside of the atmosphere, indicates some a significant sensor visual capability for China. Here you can see the dates for the different interception of targets by China, indicating the evolution of their missile defense capability against incoming ballistic missiles. In 2013, China tested an ICBM with decoys. Now, some of these are just cheap inflatables. Others are actually electronic warfare platforms that deliberately interfere with the incoming interceptors. The bus of a missile could carry the MIRV multiple independently targeted reentry vehicles, could number up to 10, and half of those could be assorted decoys. Now, China also launched 3 ASAT mini satellites, SY-7s. These are little satellites that would move up next to other satellites and blow them up like a space mine. In theory, it's illegal to militarize space, so these were temporary launches. During the Cold War, the Americans accused the Soviet Union of engaging in a lot of this type of activity, but when the Cold War ended, the Pentagon stopped its accusation of these 100 space mines. So it's very likely that China does not have any space mines at all. It might just simply be an accusation by the U.S. based upon testing behavior that they've observed. In 2013, North Korea conducted its third nuclear test. Now, what didn't happen in 2013 and has not happened since is China did not restate its no first use pledge in its defense white paper, which it had done before. Earlier, China had promised never to be the first country to use a nuclear weapon, and it has not reaffirmed it since. But of course, it's not as a policy of ambiguity contradicted it either. I think the conventional wisdom is that China is tempted by the benefits of using tactical nuclear weapons in the air and at sea in a conflict with the U.S. over Taiwan. And there's huge advantages to using a weapon first, and to deter the U.S. by compelling the U.S. Navy to disperse in order to avoid the effects of a nuclear attack. If you look at other countries here, India's also made a promise of no first use. Countries like the U.S., England and Pakistan have not excluded a preemptive strike ever, and this also implies the same policy among any NATO country that possesses duly shared U.S. nuclear weapons. Countries like France may use nuclear weapons first, but they would do that after launching a warning attack initially. Russia has declared that they would use a nuclear weapon first if they were threatened. North Korea, of course, has not declared a specific nuclear weapons launch policy. In 2014, China deploys its ballistic missile submarines to Sanya, which is a base in Hainan, and it's trying to take advantage of the South China Sea. The problem is that the continental shelf off the coast of China is about 150 meters deep. In other words, if you stick an aircraft carrier on its end, it would stick out of the water. You can almost visually identify submarines that are in the water. They can be acoustically picked up quite easily despite the clutter of the shallow waters. You could have drones moving in the shallow waters. You have, of course, Korea, Japan, the Senkaku Islands and the Ryukyus. The Senkaku Islands are actually on the continental shelf along with Taiwan, where the Ryukyus are not, but they're very close. So there's a whole set of sensors that could be deployed by forces hostile to China to detect the submarines. Even the northern South China Sea is exposed because there are islands there that are not possessed by China that could host American sensors or American listening devices on these islands. Plus, the Americans have already deployed drones that are doing mapping and are listening in the region, some of which the Chinese have interfered with on a number of occasions. And the Chinese are known to have deployed listening devices in the South China Sea. What the submarines really need to do is deploy in the southern part of the South China Sea, where you've got the depths that are equivalent to the Pacific Ocean. But again, the problem is those islands are heavily under dispute. Those submarines are at quite a distance. And escaping into the Pacific or into the Indian Ocean is very difficult because of all the straits that go all the way from Hokkaido in Japan down to the Ryukyus, through the Philippines, the Bashi Strait across from Taiwan, and then through all of the different straits through the Indonesian archipelago. So China is frustrated because they're not able to deploy the submarines in a nuclear bastion. And so it's thought that a closer relationship with Russia could result in the Chinese deploying their ballistic missile submarines in the Sea of Okhotsk, which is the Soviet Union's old and the Russians' current sea bastion located just off of the Russian coast of Kamchatka. And that is a deep, very large body of water protected by a string of islands and protected by the Russian Navy, anti-submarine warfare assets in the form of helicopters and aircraft, and underground sensors that would give protection to the submarines. At least much better protection than what China currently has in the South China Sea. In 2014, China conducted its first DF-41 MIRV test, which is depicted in the map, firing into the deep Pacific Ocean. China also tested the W-14 hypersonic glide vehicle, which you can see depicted at the top. This missile normally will, or rather it's the warhead of a missile, would normally move at the speed of a Mach 5 and then would drop down on a target and move at Mach 10. And so it's a very useful device for defeating the endo-atmospheric interceptors of the U.S., which are deployed at Fort Greely in Alaska and Vandenberg Air Force Base along the coast of California, as well as theater missile defenses like Aegis Ashore or THAAD or the SM-3 Standard missile deployed on warships at sea. So this is a very, very fast system. The U.S. was behind China in the system and then caught up. There was a fair bit of concern in the West that this system could be used for a surprise attack, but it's not really logical, because whether China attacks first or last, or whether it attacks with a device going at Mach 5 or Mach 7 or Mach 10, there is nothing China could do to stop the U.S. retaliation. So this is a useful system for sinking ships with a nuclear warhead. It is strategically irrelevant, because while it might be able to overcome the U.S. missile defense system and therefore stop U.S. arrogance, frankly, the U.S. missile defense system can be stopped with China's non-hypersonic systems. You simply detonate a few high-altitude nuclear weapons, and then the U.S. radar system for interception no longer functions, and then China can drop nuclear weapons on the U.S. at will without interference. In 2015, China began operational Chien ballistic missile submarine patrols in the South China Sea. Again, from that location, with the JL-2 sea-launched ballistic missile, of which there are 12 carried in each submarine, China could not reach mainland U.S., but they could hit Guam, Hawaii, Okinawa, which is the American Marine base in the Ryukyus, and possibly some of the islands in Alaska. You can see on the range of missiles, like the CSS-5, which is the DF-21, which includes the DF-21D, which is used against the American aircraft carriers, the DF-3, the DF-4, which can be used against Russia and any targets regionally, the DF-31, which can hit the U.S. coast, and the DF-31A, which can hit all of the U.S., as well as the older DF-5, which can hit all of the U.S. And you can see the JL-2, which can hit about the same number of targets as the DF-31 on the U.S. west coast. If you look at the missile picture on the bottom right, you can see the DF-31 on the extreme right, and that is a solid fuel missile that you can see the size of it. It's a modern missile that U.S. is using to target, China's using to target the U.S. west coast, and the DF-31A, which can encompass the entire continental United States. In 2017, China deployed the DF-41, or began deploying the DF-41, the Chinese SS-20. So far, 24 have been deployed. These are China's most powerful and latest ICBMs. First, they have a 13,000 kilometer range, which means they can reach all of the continental U.S. They have a 100 meter circular error probability. That means 50% of the time they'll hit a target within 100 meters. In other words, they're incredibly accurate. Now, they're not accurate to the accuracy of 10 meters, which might matter if you're trying to blow up silos, which means the Minutemen III silos in the U.S. may still be survivable from these missiles. But in theory, each missile has a MIRV of 10 rockets, multiply independently targeted vehicles, that's 10. And so 24 of these launching would, in theory, put 240 warheads on the U.S. Now, it's not thought that China's got enough warheads for these rockets, so there could be as few as 3 warheads per rocket, and the rest of the payload are decoys, and so that would be 72 warheads. But these are megaton range warheads, it's thought, and that would be aimed at the 72 largest urban centers in the U.S. And this would easily overwhelm a U.S. missile defense system. Now, if China were to build 100 of these, again, mobile systems, that would be 500 warheads. Now, China's got about the same highway network as the U.S. It's about 80,000 kilometers of highway. But having these move along the highway would be highly disruptive and in some ways very vulnerable. So it's thought that China's going to put some of these into silos. This is the current strategic threat that the U.S. is facing from China, and they've only begun deployment in 2017, and it's the availability of these that's thought in some ways to be contributing to China's steadfastness on foreign policy. In 2019, there was a lot of hype in the news because China launched the DF-ZF Wu-14, which is the hypersonic glide vehicle, and it became operational with these various launchers. So the missile only has to launch the missile a short distance, and it puts the hypersonic vehicle in the atmosphere, which then moves at enormous speed. And again, it's meant to move fast enough that it overcomes the layers of U.S. Ballistic missile defense. Also in 2020, the Chinese finally completed the deployment in June of 2020, the 30 Beidou Global Positioning System satellites with accuracy of 4 meters, which means it has military applications, just like the U.S. Navstar system. So it was originally thought there were going to be 36 satellites. The 30 that were deployed are not all the same. Some of them have varying functions, but they essentially transmit information allowing Chinese air, naval, ground, and missile systems to achieve a higher level of accuracy. In 2021, it was observed from satellite photography that China was building in various different parts of China, but essentially 3 separate main areas, over 300 silos, likely for the DF-41 ICBM. These different silo sites would be separated by a few kilometers. They would contain the silo facility plus the launch module, or the command module that would be built underground. And all of these different construction sites, some of them have been put under construction covers, but it's very obvious what the purpose of these are for manufacturing. The design of this cluster is that if an incoming missile attacked, it would destroy its fellow missiles that would be flying nearby, and on their detonation it would put up so much dust it would be not clear precisely what had been hit and what hadn't been hit. So it's an old concept that goes back to the 1980s about how to have missiles put into the ground. The U.S. has 3 fields of Minutemen III ICBMs deployed in silos across the U.S. countryside, and they're widely separated. So you'd have a missile silo right next to a farm, and there's local security, but also the farmers can see who comes and goes, and so it's deployed in the interior of the U.S. So if a submarine launched a cruise missile or a ballistic missile on the Atlantic or Pacific coast, you'd have about 20 minutes before those missiles struck the silos, and so the silos would have enough time to be launched. That's called launch under attack, LUA. And so China seems to be building these for their DF-41 ICBMs that they already have deployed as mobile systems. You can see depicted here the different locations of those silos. You've got construction at the Yumen missile silo field, as well as the Hami missile silo field. It's 110 and 120 silos deployed there, as well as smaller number of silos for the DF-5 missiles. These are the old missiles from the 1980s, the liquid fuel missiles in central China. And Jilantai training area, you've got 14 silos manufactured as well. You can see the different ranges to the different silos. When I flew to Beijing from Montreal, I flew from Montreal over the Hudson Bay and then directly over the North Pole and then landed in Beijing. So you can see the logic here. To fire a missile at Los Angeles from central China, or what looks like Gansu province, you'd be firing it basically over Mongolia and over Russia. Now this is problematic. A Russian sensor system caught up in a Chinese-U.S. missile engagement would have most of the missiles flying over Russia, which would severely complicate deterrence for both the U.S. and China. Russia might launch on either or both countries if it's not advised that it was going to have missiles flying over its territory, which may not occur in a launch under attack or if the command structure of either country is disrupted by a high-altitude detonation that cuts out the communications. In 2021, July, there was also a FOBS test, a fractional orbital bombardment system. What this means is that this was using the hypersonic missile. So you would launch this hypersonic missile, it would go into orbit at an enormous speed, and it would become exoatmospheric, flying at enormous speed in space. Now the problem with FOBS is that it's essentially a surprise weapon. Now it's illegal under international law, to militarize space. So with FOBS, you would launch this warhead into orbit. Now, you can see a rocket launching because of the fire coming out of the back of the rocket. The rocket you see on the right was launched in August, and it launched a dummy hypersonic warhead that was a part of the fractional orbital bombardment system. Now, the Soviet Union first developed the FOB system in the 1960s, and it conducted a test in 1969, and it put into orbit a warhead. Now, this warhead was no longer observable. It's a small object. It's flying outside the atmosphere. There's no fire associated with it. It's not coming back into the atmosphere, so it's not visually detectable or detectable by radar near the ground. And it would fly over the U.S. from over the South Pole. So it would fly over the South Pole, come up through South America, over Mexico, and then enter the U.S. from Mexico. And then a command could be given that this warhead would come out of the sky at enormous speed because it's exoatmospheric. It's flying out in space. So it's flying much more quickly than a normal ballistic missile. And it would just drop onto a U.S. command center. Now, this made the U.S. very insecure. And for some reason, the Soviets stopped the development of FOBs. Probably because the Americans were going to do the same to Russia, probably because it was going to intensify relations against the U.S., because the Soviet Union was hoping that they could achieve détente with the U.S., where they would be able to consolidate their gains in the developing world and in Europe. And the Soviets had finished building up their missile forces to about 1,000, not including the warheads on them. And they would add another 300 missiles by 1979, up to 1,300. So various political reasons why the Soviets never implemented this system. Again, a surprise attack on the U.S. would be inconsequential since many of the U.S. nuclear assets were deployed at sea and would, 2 hours later, retaliate with almost the same effect. It would be, however, useful to destroy American bombers on their tarmac and with some level of accuracy, some of the missiles deployed at Minot Air Force Base and Maelstrom Air Force Base and the other ICBM fields, if the FOBs was accurate, which the Soviet FOBs was not. So there was a possibility of an extreme surprise attack that would take out the least technologically advanced parts of the U.S. strategic arsenal. Furthermore, you can see from the graphic on the left that FOBs, because it flies in the atmosphere when it descends, flies so low, it flies below the radar limit. Because the radar, of course, is limited by the curvature of the Earth. It can't look around the Earth, so it basically is a straight line from wherever the transmitter and the receiver is for the radar. So it's able to, unlike a ballistic missile, which you can see flying in an arc, so you can detect them going into space. Although here the ballistic missile trajectory is significantly exaggerated. The American Pershing II missile in Europe had a very flat trajectory, which had many of the same characteristics as a FOB, because it could hit Moscow within 5 minutes, and it went below a lot of the Soviet radar sort of perspective. So in 2021, China launched the 4th, 5th, and 6th Type 094 and 094A Jin ballistic missile submarine. There's a possible 7th and 8th boat under construction. Now, we don't know when the 4th, 5th, and 6th were manufactured. They suddenly appeared on the scene, so it seemed that there was a fair bit of successful covert manufacturing being conducted by China, but Xi Jinping did attend the commissioning of the 6th boat in 2021. So these are operational. They operate in the South China Sea. Constrained waters don't take full advantage of range. Now, the problem with the Type 094, like the Zia class, is that it was 2 orders of magnitude louder than even the Soviet, or now the Russian Delta III ballistic missile submarine. And the Type 094A, which is also called the Jin 2, is a much improved system. Now here in the graphic on the right, it indicates that they're carrying the JL-3 missile, which is not true. They are still carrying the JL-2 missile. In 2030, it's estimated that China will have about 1,500 ICBMs and sea-launched ballistic missile warheads, although it should be pointed out that this was originally the number estimated for 2025. So it's a moving target. China seems to be developing warheads slower than is expected, By comparison, the Soviet Union went from a handful of intercontinental ballistic missiles in 1960, before the Cuban Missile Crisis, and achieved 1,000 warheads that could be launched by missile by 1970 and 1,300 by 1979. So China's, the number of missiles that they're making launchable is essentially a fraction of what the Soviet Union had. By 2040, it's thought that Chinese could achieve nuclear parity with the US and Russia, presuming the US and Russia don't build up their nuclear weapons. Now, Russia might be facing significant economic limitations on that. Nuclear warheads tend not to be that expensive. They'd be several $million, but the missiles are expensive, and especially the overhead for maintaining the missiles, the submarines, and the bombers. At the height of the Cold War, between 1959 and 1961, the U.S. was manufacturing one thermonuclear warhead in the sub-megaton range every 58 minutes. So within a week or two, the Americans built more nuclear weapons than India, Pakistan, Israel, France, North Korea, and England put together. So the U.S., if it needs to, can manufacture an enormous number of nuclear weapons under a very short period of time. China's not there yet, nor does the U.S. consider it desirable to manufacture that nuclear weapon, not because of the obvious instability that could be created with China. I mean, both countries have some level of second strike capability, but because the developing world today is getting very close to easily achieving the technology that China and other nuclear powers achieved in the 1950s and 60s. And so it would encourage a great many countries in the international system to equip themselves with nuclear weapons, like South Korea, Japan, and other countries in the international system. Now, we can compare China to the world's total number of nuclear tests. You can see where the nuclear tests were conducted. As a general rule, nuclear weapons are tested on indigenous land. For the UK, they tested it in Australia. The French tested it in Algeria and the Pacific. The Americans tested it in the Pacific and on the islands of Alaska and in New Mexico. India tested it in the Rajasthan desert, the Pakistanis in Balochistan, Israel on Prince Edward Island in South Africa, China at Lop Nor in Xinjiang, where the Uyghurs live, and Russia in Kazakhstan and Novaya Zemlya, and in a great many locations across their territories there. So the U.S. is the leader in testing. They've conducted 1,054 tests. The Soviet Union conducted 715 tests before they ceased testing. France conducted 210 tests. And China is on par with Great Britain for 45 tests. And the remaining tests are Indian, Pakistani, North Korean, and Israeli. In terms of nuclear facilities, China's got a number of major uranium mines, most of which, the large ones, are located in Guangdong, Jiangxi, Hunan, and also Zhejiang and Guizhou were opened later on. Focusing on a specific uranium mine makes sense when you're looking at a small country, but for a big country like China, there's actually multiple mines. The U.S. had over 500 different mine sites for uranium in the 1950s through the 1970s, some of which were more productive than others. For uranium enrichment, particularly gaseous diffusion, there were 3 sites in Jiuquan in Xinjiang, Taoli in Beijing, and Lanzhou. At Taoli in Beijing, that was obviously a research facility. China obtained centrifuge technology, where you take uranium hexafluoride and you spin it. This is you might have heard the news of the Iranian system. And the uranium-235, which is lighter, is pushed to the center by the heavier uranium-238, which is pushed up by centrifugal forces by the spinning cylinder. And then you can suck out the uranium-235. And this is much faster and cleaner than gaseous diffusion. Pakistan essentially stole the technology from Euratom. A.Q. Khan did that, and then it spread to Pakistan and other places. And the parts for manufacture in Pakistan were obtained largely from the developing world, countries like Malaysia. The current technology is laser enrichment, which has not yet been operationalized, but countries as diverse as the U.S., Australia, and Israel have advertised this goal. China also has a plutonium breeding reactor at the Chien Tuition complex in Xinjiang that's co-located with its gaseous diffusion plant. So you can see that China's facilities are actually very concentrated and to some extent vulnerable, just like the U.S. facilities. China keeps its nuclear warheads in about 8 to 14 storage facilities and are typically not mated to their missiles. Unlike the U.S. Minuteman III, which they're always on a minimal alert. In other words, the missiles could be launched at any time in response to an attack. And the Russians are on a lower level of alert. You can see here in red the uranium enrichment plants that were just mentioned, and the yellow triangles are the different uranium sites that are very often associated with the large coal fields in China. These are the coal fields, and they contain, for geological reasons, the source of China's uranium. And they vary, so it's a sort of a complicated process to identify what are the minerals that are typically associated with uranium in the soil. Uranium is fairly common. It's more common than silver. And it's a heavy element, but a lot of it's contained in the continental plates because of the way volcanism works, and a lot less is contained by an order of magnitude in the oceans. So here you can get a very clear idea of the recoverable volume of uranium. Uranium has as an ore, meaning uranium mineral contained within other rock that's dug out of the ground, has been as cheap as $20 a kilo in the 1980s and 1990s. And the price oscillates based upon the amount of manufacturing of reactors. But reactor manufacturing basically plateaued in the 1990s and the early 2000s. And the Fukushima experience, the reactor meltdown in Japan as a consequence of a tsunami, slowed the development of reactors in Europe and China. China had a very ambitious reactor program. Now, what you see here is the recoverable amount. In other words, if you were going to pay 130 per kilo, how deep would you go? There are, of course, a much larger quantity of uranium than this, but it becomes enormously expensive to mine. Now, you'll notice that India and Pakistan don't have much uranium at all, so they have to find alternate sources. And this goes back to the 1-2-3 agreement between the U.S. and India, where the U.S. was going to provide energy for the Indian reactors so that the Indians could divert the scarce uranium they have into their weapons program. So China's got about 119,000 tons of uranium, which is about 1/10 of what Australia has, and less than what, say, Kazakhstan or Russia or Canada has. You can also see the large quantities of uranium in places like South Africa, Brazil, and Namibia. It's thought that Israel obtained its uranium from its close relationship with South Africa in the 1970s and the 1980s, and possibly obtained the uranium for its first weapons from Europe before that date. So China has mining interests in Niger, and it's thought that China is obtaining some of its uranium from Niger as well. Here's another graphical representation of the amount of uranium being mined in kilotons in 2016. And it should be pointed out, there's a certain irregularity every year depending on demand, depending on what reactors are being built, and with the opening and the closure of mines, certain uranium sources no longer become productive. And you can see, for example, Canada has a had a large share of world production in 2016. And this again is putting in perspective a comparison between the production levels of different countries in the world. and China is not even represented here in terms of production. So clearly China has an issue in that it depends on imports of the uranium it needs in order to build a large nuclear arsenal. And this could definitely be a factor in its nuclear weapons program. Here you can see the different strategic locations that were identified earlier. These are missile centers rather than nuclear centers. So you can see the Xi'an Satellite Monitoring Control Center, the Jiuquan Satellite Launch Center, which is co-located with their Nuclear Development Center, the ASAT facility in Xinjiang, the Large Phased Radar that's located nearby, Beijing Aerospace Command located around, well, Beijing, another ASAT facility, Tafei and Mianyang, and the Launch Center at Xishang Satellite Launch Center, and you've got over-the-horizon satellites that are aimed in the direction of Taiwan. So China's warhead rate of production was estimated to be at a maximum of 50 warheads per year between 1970 to 1990, for a total capacity of around 1,500 to 2,000, but with as few as only 300 to 500 actually manufactured and operational, although many of the warheads might have been decommissioned. There simply is not a lot of information on this. Again, the U.S. manufactured one warhead every 50 to 60 minutes between 1959 and 1962 for a total of 11,000 warheads per year for a net total of 71,000 between 1945 and 1994. Where nuclear weapons manufacturing constituted about 15 to 20% of the U.S. defense budget, for China it was it's been about 5% from 1965 to 1979 and somewhat more after, but generally China has invested less and therefore had a much smaller arsenal. In 1964, China made its most important policy declaration, which was a pledge never to be the first country to use a nuclear weapon. It's the NFU, or the No First Use Pledge. Although, as mentioned earlier, it was not renewed in the 2013 Defense White Paper, which raises questions about China's current policy. Now, this is highly circumstantial, as China has considered using nuclear weapons against the USSR in the event of an invasion, and certainly has considered the implications of nuclear weapons use in a conflict with the US over Taiwan. Compared with NATO, which reserves the right to use nuclear weapons first, China's a lot more appeasing with regards to its nuclear strategy. China has also promised the non-use of nuclear weapons, or the threat of, or the promise not to threaten use of nuclear weapons against non-nuclear weapon states. You can see here a number of the Chinese missiles, including the enormous DF-5, which is the very old ICBM, of which China's got 18, built in the 1970s and deployed in the 1980s to 2000, and the DF-41, which is the current solid-fueled, mobile and siloed ICBM that is the mainstay of China's deterrent against the U.S. since 2017. You can see the various bases located in China, and there are additional new brigades. Those are actually brigade numbers for the different bases. So, Chinese nuclear doctrine. From 1964, China affirmed that nuclear weapons are primarily for deterrent purposes. It therefore buys into the conventional strategic wisdom accepted by almost all of the other nuclear military powers. From 2006, China's nuclear doctrine has evolved some elements of war fighting. So this is a credible minimum deterrent doctrine. The idea that a small arsenal that threatens the probability of retaliation. So China doesn't guarantee that its entire arsenal will survive, but the probability is that most of the arsenal will survive, and that will provide a sufficient deterrent, even against a country as large as the Soviet Union, Russia, or the US. Now, there are some new discussions. Some thinkers in China have talked about counterforce doctrine. This is using nuclear weapons against military targets instead of hitting cities. In other words, Chinese missiles attacking enemy missile silos or enemy submarine or enemy air bases where nuclear weapons might be deployed. China's gradually acquiring the technology to do this. But to do this, you have to be both timely, have excellent intelligence, and have very accurate missiles, something which China doesn't have in large quantity. The second issue is escalation dominance. The idea that to deter the use of nuclear weapons within a war, meaning once the war's already started, to keep the other guy from using nuclear weapons. And for China, this would be to keep the U.S. from nuclear weapons even when the U.S. is losing over Taiwan in a conventional fight. Or to control the nuclear escalation within a war once nuclear escalation has begun within that conflict. Now, escalation dominance means that, if you escalate and I escalate to counter you, and then you escalate against me, and then we carry this to the ultimate conclusion, who is going to inflict more damage? Now, in a strategic exchange between the U.S. and China, it's about even. They're both going to blow up all of their cities. Now, probably at the moment, the U.S., with its thousands of nuclear weapons, is going to inflict enormously more damage on China. But in a conflict over Taiwan, China can deploy probably more nuclear weapons more easily than the U.S. can in the immediate vicinity of Taiwan, because China's right next door. So the theory there is China's got nuclear escalation. So if China invades Taiwan and the U.S. loses and the U.S. considers using nuclear weapons, the U.S. will not use nuclear weapons, because they'll recognize when they war game out the conflict that China will ultimately win. It'll have escalation dominance. Now, it's not certain that China has escalation dominance. The U.S. has much better command and control. It has a history of doctrine and experience with tactical nuclear weapons. So perhaps the U.S. has escalation dominance over Taiwan, and then China has to explore ways of achieving escalation dominance. Number 3, tactical nuclear warfare. Now, it's thought that China has had tactical nuclear weapons in the literature, although I mentioned earlier that they didn't. Almost certainly, all of these would have been airdropped in some sense, although it's not clear how this would have been deployable against a Soviet attack. They would have nuked all of China's air bases. China, in theory, is acquiring the technological capability to use local anti-ship missiles with nuclear warheads for this tactical purpose. China may eventually come to use tube and missile artillery for this purpose as well, as the U.S. and the Soviet Union did in Europe during the confrontation there between NATO and the Warsaw Pact. And this would give tactical forces significantly more flexibility. Not only air forces dropping tactical nuclear weapons, but ships chasing submarines, ships firing on other ships, and military forces using battlefield nuclear artillery, rocket-borne and artillery-borne. Some PLA theorists believe that nuclear war is most likely to occur at the theater level between military forces. Now, there's a couple of issues, and the first issue is China's small and vulnerable arsenal. China's had very few and preemptible nuclear forces. It had 20 ICBMs, the DF-5s, which were liquid-fueled and stored in caves, providing several hours warning of their launch to U.S. overhead satellites. China had no second strike capability until essentially 2017, when the DF-41s could reach all of the U.S. efficiently. Although the DF-31A could, but they were not in the same numbers. So the strategic thought in China was that it only had to have enough surviving missiles to threaten Moscow or 2 American cities like Los Angeles and Seattle. It didn't have to guarantee the complete destruction of all of the U.S. cities. Now, China's maintained a relatively small arsenal for 3 reasons. 1, the high cost and limited resources available within China up until the 1980s. 2, the desire to avoid provoking the U.S. in the 1980s or Russia in the 1990s, both times when China had an advantageous position to trade or have technology exchange with these countries. And 3, the political cultural belief that goes back to the very beginning of China, the idea of Mao that China was nuclear indestructibility. Now, this is a part of early rhetoric, but it's partially believed because China's so large and it's survived so many catastrophes that Chinese essential culture will be preserved. You can always ask yourself the question, at what point will a country or a region change its identity based upon what percentage of the population is killed in an exchange? Now, the implication of this is that there's a concern and interest into when China is going to achieve a nuclear breakout. Even if China achieves 1,000 warheads or 1,500 warheads, that's far less than the 55,000 manufactured by the Soviet Union. Between 1960 and 1980, the USSR expanded its ICBM arsenal from 0 to 1,300 by 1970 to 1,398. Along with much improved MIRV technologies at the end of that decade, which gave it a lot of security. China is an order of magnitude less in terms of numbers of warheads. Here you can see various projections for Chinese missiles, and you can already see the total warheads for about what we are now in 2023. And here it says the warheads, number of ICBM warheads is expected to go past 100, and they've already gone past 100. So this is an estimate done almost 15 years ago, showing that China is going faster than these conservative, multiple conservative estimates. The second issue is China's proliferation agreements. China initially advocated nuclear proliferation because it felt that both the US and Moscow were seeking to keep it disarmed. Once it obtained nuclear weapons, unsurprisingly, it affirmed a policy against sharing nuclear weapons, which is enunciated under Marshal Chien Tuition in 1965 with other states. Now, it did violate this in the case of Pakistan, but largely in response to India's peaceful nuclear explosive, which was detonated 12 years after the Sino-Indian conflict of 1962. China and the USSR colluded over the nuclear disarmament of North Korea. North Korea attempted to acquire nuclear weapons from the Warsaw Pact, and the Soviet Union blocked them, although they did provide North Korea with surface-to-air missiles. Ultimately, North Korea obtained advanced missile technology from Egypt, which was at that time an American ally. Got some Scud missiles and were able to reverse engineer them in time to sell them to both Iran and Iraq during the Iran-Iraq War. This obviously caused a great deal of difficulty between Egypt and the U.S., since Egypt for some reason, didn't anticipate the U.S. reaction. But, it should be clear, it wasn't China that gave North Korea missiles. It was first the Soviet Union in the form of surface-to-air missiles, and then it was an American ally, Egypt. Now, the nuclear reactors in North Korea were provided by the Soviet Union. These were research reactors meant for energy production, not nuclear weapons production. They were repurposed by North Korea. The North Koreans had the weapons deployed where the old Japanese Army nuclear weapons program was conducted at Yongbyon, which was evacuated by the Soviet Union when they invaded North Korea at the end of the Second World War. But was a useful site for replanting the energy systems for a reactor. Now, China and the U.S. have come to an understanding not to proliferate nuclear weapons in Asia. The U.S. pressured Taiwan and South Korea in 1975 and 1985 to halt nuclear weapons-related research, and has actively discouraged Japan and Australia from seeking nuclear weapons by providing explicit extended nuclear deterrence. Now, South Korea and Taiwan had both experimented with nuclear weapons in the 1970s as a part of the fear that the U.S. defeat in Vietnam would cause the U.S. to disengage from Asia. And the U.S. wanted to reassure their allies that they would not leave, although there were some elements in the U.S. government that did want to leave Asia and let South Korea defend itself. In 1985, South Korea and Taiwan again developed nuclear weapons, largely in anticipation of threats. But ultimately, again, they were canceled under more explicit threats by the U.S. government. For its part, China agreed with the U.S. to cut back on its nuclear missile support to Iran and to Middle Eastern countries and to refrain from sharing nuclear weapons generally. Although this might be under threat following a 2022 strategic agreement between China and Iran. Now, this agreement broke down over Pakistan and India several times, where the U.S. backs India and China's backed Pakistan, their respective allies. Now, the third issue is espionage. The U.S. Cox Committee in 1999 concluded that through espionage, China had acquired sensitive information from the U.S. in the 1980s and 1990s from various sources covering, in particular, the W-88 Trident warhead, which is depicted here, the W-78 Minuteman III Mark 12A warhead, and the W-87 Peacekeeper ICBM warhead, and the W-70 neutron bomb warhead, and nuclear tube artillery warhead. The W-88 warhead is important because it's the U.S.'s most advanced warhead on its most important missile, the Trident missile, which is deployed on the Ohio ballistic missile submarines that are deployed at sea and are America's true second strike deterrent. These are very light warheads that are very accurate and produce an enormous explosion. And they're basically the state-of-the-art technology. It's not known how China acquired the information, but the U.S. discovered it when an embassy of theirs in Southeast Asia had an individual from China deliver the plans. So clearly China had successfully infiltrated the U.S. nuclear weapons manufacturing complex, and they have never successfully caught the spies that stole the technology. China's 1988 neutron bomb test was possibly based on U.S. nuclear engineering obtained by China through clandestine means. The fourth issue are nuclear bastions. Ballistic missile submarines require protection. In other words, they need to be able to go to 300 to 400 meters below the surface of the ocean in deep waters and to spread out over a great area where a MAD, or a magnetic anomaly detector carried on the back of an aircraft, won't detect them. For the U.S., they have the large Atlantic and Pacific Oceans to exploit for this purpose. And the long range of the missiles from the ballistic missile submarines means that these submarines don't have to be anywhere close to the U.S. or their target in China. If a ballistic missile submarine is destroyed, China would then be exposed to a nuclear first strike that would wipe out its land-based nuclear weapons, the ones in the silos, the ones that are mobile, and the ones that are just stored in caves and in warehouses. Only the very restrictive Bohai Sea provides China space for its ballistic missile submarines, since operating on the coast is too shallow and exposes these submarines to attack by enemy submarines, maritime surveillance aircraft, and various subsea drones. The problem with the U.S. U.S. and Chinese continental shelf is that they're very shallow, and China's continental shelf is extremely long. It extends all the way out to Japan. In fact, there's no deep water between China and Japan, or China and Korea, and China and Taiwan. And you can see from the undersea topography that even the South China Sea is a little bit too shallow, except in the very southern part of the South China Sea, where you start to get depths where submarines can hide. Unfortunately, China does not have exclusive control over the South China Sea, which is very problematic. So, a desirable location would be the Sea of Okhotsk. Now, the Sea of Okhotsk is that Russian territory between Sakhalin and Kamchatka. Now, if you see on the bottom left, you see a red arrow. That red arrow takes off from the Bohai, which is a continental sea off the coast of China. It flies over what is Jilin and Heilongjiang, over the Russian Far East, and then you have that body of water. It is on the continental shelf, but it's very, very broad, and it's deeper than the rest of the continental shelf. And Russia could one day give permission to the Chinese to deploy their ballistic missile submarines there. And this would also put them within range of the continental U.S. Here you can see a much closer view of the topography of the Pacific, which is where the U.S. submarines are. For China to deploy into the topography, they would have to run the sensors on the Ryukyu Islands, or break into the Sea of Japan through the Tsushima Strait, or through the Bashi Channel between Luzon and Taiwan, or between any of the other channels in Indonesia. And to come back, they would also be could be targeted and detected and destroyed. So China's very small number of ballistic missile submarines would be made vulnerable by movement through these spaces. So U.S., British, and French ballistic missile submarines operate within the deep ocean, And Russian ballistic missile submarines, on the other hand, because they're louder, generally operate in bastions like the Sea of Okhotsk and the Barents Sea near the Arctic Ocean. And so the Sea of Okhotsk and the Barents Sea are patrolled on the surface by the Soviet Navy, including helicopter carriers whose prime mission is anti-submarine warfare against American or threatening hunter-killer submarines. So where the U.S. submarines will go into the vastness of the ocean, the Russian submarines will go into areas that are heavily patrolled by surface ships near the Russian coast, and essentially to protect these against enemy air and submarine threats. The fifth topic are countervailing nuclear forces. China's principal nuclear adversaries are the U.S., the USSR, Russia, and India, all of which have territorial disputes. In the case of the U.S., it's over Taiwan. China, furthermore, has nuclear-armed allies on its border, including North Korea and Pakistan, and neighbors that have threatened or are capable of acquiring a nuclear arsenal, like South Korea, Taiwan, and Japan. North Korea's arsenal is quite small, and Pakistan is friendly with China, as is South Korea. Japan would pose a significant threat to China if it nuclearized, given its capacity for exploiting that technology. Taiwan was in a position to exploit a nuclear option in the mid-70s and the mid-80s, but is under far too much Chinese surveillance for it to achieve such a capability overtly today. You can see those are various airfields that were targeted during the Cold War and likely would have been subject to a nuclear attack in the event of a nuclear exchange during the Cold War. This is a Chinese map showing the various different locations of the missiles. This is a map that I produced identifying the different bases with estimates of the missiles. Although this might be dated because it's based on the 2010 military balance, but you can easily update the precise number of missiles at each of these locations. And if you refer to my earlier lecture on the Arsenal of China, lecture 2, you'll get an accurate count of the actual missiles. Here are the ranges and the graphic representation of the different missiles. You can see the DF-5, which has the longest range at 13,000 kilometers, which is similar to the DF-41. The DF-31 and the DF-31A have a shorter range, but enough to encompass most of the continental U.S. Again, you can see the DF-31 on the extreme right and compare it to the legacy Russian rockets. The more modern Russian systems are the SS-19, SS-24, the SS-25, and the SS-27. The SS-18, Mod 4 and Mod 5 are still the world's largest ICBMs in terms of payload carriage, and the Russians still use these missiles, although these missiles were manufactured in Ukraine, so Russia is not in a position to be able to replace them. And these are the ranges of the different Chinese missiles, and you can see how the DF-31A can reach all of the U.S. The JL-2, in theory, can reach a part of the West Coast. And the DF-5, of course, can encompass all of the U.S. Yeah, here you can see the JL-2 being launched, the JL-2 under development, and the Chien-class ballistic missile submarine that would launch the 12 rockets. So China's first opponent is India. India has had about 90 warheads, and it's up to about 150. Perhaps 20 Agni missiles are capable of reaching China. India's ballistic missile submarines are currently not equipped to strike China because they have warheads that can reach just barely into China from the Indian Ocean, but they'd be mostly striking at empty Tibet. India also has about 50 air-deliverable warheads that could be carried by India's Mirage 2000 fighter bombers. U.S. is a peer competitor to China, and for precise details of the location and number of missiles and air assets and naval assets, you can consult the updated 2023 simulation for the East Asian crisis simulation game. So the U.S. has 14 Ohio ballistic missile submarines, each carrying 24 Trident D5 sea-launched ballistic missiles, which are very accurate. Each of them contain 8 475 kiloton warheads for a total of 2,688 warheads. The U.S. also has 400 Minuteman ICBMs, which is a modification from what they had. They've lost 50 of those in the last 10 years. These currently carry 1 warhead, but they can be equipped up to 3 warheads, but they're currently restrained on 1 warhead, not to cause insecurity. Although estimates are that the U.S. has about 6,000 and something warheads, looking at the numbers, including warheads that are not accounted for, there are about 1,300 nuclear aircraft bombs, 1,600 nuclear cruise missile warheads, about 3,000 tactical nuclear warheads, of which about 3,000 are operational and not in storage, out of a total available of 5,000 to 8,000. The U.S. had a peak arsenal of 31,255 warheads in 1967 out of a total of 72,000 manufactured between 1945 and 1994. You can see here the Minuteman III, and you can see a drone stealth aircraft conducting a carrier landing that can be used to deliver nuclear weapons. The principal ICBM fields for the Minuteman III are at Malmstrom Air Force Base, Minot Air Force Base, and F.E. Warren Air Base. You can see the 2 ballistic missile submarine bases in Silverdale, Washington on the Pacific coast, and Kings Bay, Georgia on the Atlantic coast. And you can see Whiteman Air Force Base and Barksdale Air Force Base that contain a lot of the B-52s that are tasked with the strategic bombing mission. These are the different sensor systems. You can see that the one in Cape Cod does look over the Caribbean to deal with a fractional orbital bombardment system that comes from over the South Pole. But most of the sensor systems are aimed over the horizon at the Eurasian landmass in anticipation of a missile attack from mainland China and the Soviet Union. And the rest of the sensors look over the Pacific and the Atlantic Ocean for submarine-launched missiles. You can also see supporting sensors in Thule, Greenland, which is a Danish territory, and Fylingdales in England. These are the different missile interceptors that the U.S. has deployed. Short-range against short-range ballistic missiles, medium-range ballistic missiles, intermediate-range ballistic missiles, and intercontinental ballistic missiles. There are 2 ICBM interception bases, one at Fort Greely, Alaska, and one at Vandenberg Air Force Base in California, and they both look out towards the Arctic and towards the Pacific at missiles that would come from North Korea and China, in addition to a whole slew of other interceptor systems. Here you can see Aegis ashore and Aegis on a ship, THAAD PAC-3. The Russian nuclear capability is 7 Delta III and Delta IV. These are legacy ballistic missile submarines from the Soviet Union. 1 Typhoon, which is used for training, and 4 Bori ballistic missile submarines. And they carry about 1,000 warheads on the assorted different missiles that are carried by the submarines. Russia has 339 ICBMs, some of which are mobile, but most of them are deployed in silos. Some of these are MIRV and have multiple warheads. There are about 1,000 sea-launched nuclear cruise missiles, 500 air-launched cruise missiles with nuclear warheads, and about 3,000 tactical nuclear missile warheads. Again, estimates are that Russia's got about 6,000 warheads in storage, but it's really it's not a transparent system, and so it's very likely that Russia can have up to 10,000 warheads available in various states of storage. The Soviet Union's peak arsenal was 46,000 in 1988 out of a total of 55,000 warheads manufactured. In other words, the Soviet Union retired very few warheads. Less than 10% of the warheads they manufactured were retired. They just kept manufacturing and keeping them. This is an old map of the different ICBM fields that were there in the Soviet Union. This is from a French military publication. Many of these fields are repurposed and still in use for the new Topol M class of Russian ICBMs. This is the up-to-date location of the different systems, in particular the SS-27, the SS-25, and the SS-19 Topol-M. The SS-18 in green are the large, heavy lifters that are aimed at North America. And these are very large missiles that carry 10 warheads each, and would be the type of missiles that would be fired over the Arctic at the US and Canada in the event of a nuclear exchange. So, nuclear strategy considerations. Now, China's been building up its nuclear arsenal to deter the U.S. from protecting Taiwan or other states from a Chinese attack. The Chinese have asked whether the U.S. is willing to risk the death of over 100 million Americans for Taiwan. The U.S. may judge it is worth escalating a war over Taiwan rather than lose over Taiwan and have to confront China later over Okinawa or Guam. The U.S. and the USSR developed similar doctrines, a limited war, or how to fight a small conflict under the threat of a nuclear attack. Generally, the winner is the state with the greater interest and therefore the greater willingness to start a nuclear war. The U.S. and China must therefore convince each other that they are the most serious over Taiwan. Taiwan is defending the principle of Chinese reunification versus the U.S. principle of democratic self-determination. The U.S. may believe that Adolf Hitler's attempt to reunify with Austria did not end Germany's territorial aspirations. Right? So the U.S. has faced, and European countries have faced this kind of threat before. And the Russian war over Ukraine, started in February of 2022 by Russian President Vladimir Putin, is in some ways associated with having to liberate Luhansk and Donetsk and Crimea, which are possess Russian populations that want to be more with Russia than with the Ukraine. So there we've got the principle of self-determination against the territorial integrity of Ukraine, and questions about whether nuclear weapons would be used and escalated in those contexts. Now, China may come to believe that a strong Chinese nuclear arsenal will neutralize the U.S. nuclear arsenal, rendering a conventional war safe against the U.S. This is termed the stability-instability paradox, and may or may not lead to escalation. And it argues that in perfect stability, nuclear weapons cancel each other out. So China engaged in a border war with the USSR in 1969, inspired by the Cultural Revolution, and under a weak Chinese nuclear umbrella made it possible just to focus on conventional forces. Now, there are ways to deal with a threat of perfect stability. The way the US dealt with it during the Cold War was to tell the Soviets that in the eventuality of a Third World War, of a conventional conflict over, say, West Germany, the U.S. would send conventional submarines and aircraft carriers to hunt down and destroy the entire Soviet ballistic missile submarine fleet. So they would burst into the Sea of Okhotsk, seize the islands with Marines, or move into the Barents Sea, destroy the Soviet surface fleet, and then to chase the Soviet ballistic missile submarines under the Arctic ice, one by one, until they were all destroyed. At the completion of that, no nuclear weapons were used, but at the completion of that, the Soviet Union would have no second strike capability, because the U.S. had enough accurate ICBMs. They could then systematically destroy in a surprise attack the entire Soviet siloed arsenal and bombers at the airfields. At the end of that, the Soviet Union would be completely exposed and would have to surrender. So similarly, in a conflict over Taiwan, the U.S. would target the 6 to 8 Jin ballistic missile submarines. It would use conventional weapons from B-2 bombers to hunt down and destroy each of the mobile Chinese DF-41s and systematically destroy, using drones, the different DF-41 missiles and the DF-31 and DF-31A missiles deployed in silos. Once those missiles are gone, China can't fire anything at the U.S., and the U.S. can dictate terms. So this conventional counterforce strategy developed during the Cold War could be used to deter China from exploiting the stability-instability paradox by using a smaller nuclear arsenal to cancel the U.S. nuclear arsenal, thereby allowing China to use its superior conventional force to eventually win with attrition over Taiwan. Now, nuclear weapons can also be used for general deterrence. So China may be seeking a nuclear arsenal to create a sphere of influence that includes general nuclear deterrence. General nuclear deterrence is a situation where a state's military arsenal is so powerful that other states do not even seek competition with it. The classic example, of course, is Mexico. The U.S. nuclear arsenal is so incredibly large that Mexico does not even attempt to build a nuclear arsenal. If the U.S. arsenal was only 10 warheads, Mexico, 1/3 of its territory of which has been occupied by the U.S., may consider building up a nuclear arsenal to counter the U.S. Perhaps after a nuclear exchange, the U.S. would be weakened enough that Mexico might, in fact, attempt to build up its own nuclear arsenal to be able to then negotiate with the U.S. to reacquire some of its territory, like New Mexico. Now, China has almost certainly achieved general nuclear deterrence against Taiwan. But again, China building up a large nuclear arsenal might not create nuclear deterrence of a general nature against Japan, but might provoke it to arm. So general deterrence is overwhelmingly provocative. In other words, it'll keep some states restrained. They'll just give up and won't even compete with it. But other states might see it as provocative and actually rise to the challenge and acquire nuclear weapons. China is also aware that the continued non-nuclearization of South Korea, Japan, and Australia depends to a large extent on their belief in the credibility that the U.S. extended nuclear deterrent would be used to retaliate against an adversary, like a Chinese attack. If Japan comes to believe that the U.S. would not retaliate with nuclear weapons against a North Korean nuclear attack, Japan would embark on an indigenous nuclear arsenal. China is therefore supportive of a continued U.S. nuclear presence in East Asia, lest North Korea were to provoke a South Korean or Japanese nuclear arsenal. Now, if China continues to build up its nuclear arsenal, it would likely proceed through a number of steps already experienced by the U.S. and the USSR during their Cold War nuclear arms race. First, China would move towards counterforce targeting. Now, the U.S. did this against the Soviet Union because it wanted to threaten the Soviet Union's government, so it would destroy military targets, but also because the U.S. could do a preemptive attack on the Soviet nuclear arsenal just as it's about to launch if the U.S. had superior intelligence from human intelligence or from overhead satellites, and that would disarm the Soviet Union, and then the U.S. could negotiate to keep the Soviets at peace. The Soviets targeted NATO nuclear weapons before they used nuclear weapons in order to make NATO more likely to negotiate. Because if NATO ran out of nuclear weapons, they wouldn't then be able to resist a Soviet attack and be more likely to negotiate. So China might do this. They might target U.S. nuclear weapons. Now, the Soviets did this with reconnaissance forces. One of my teaching assistants was a former colonel who in his younger days was in a recon element of a motor rifle regiment in Czechoslovakia. And his job was to jump ahead and identify and destroy American nuclear weapons units located in central and southern Germany. And then his unit would then cut south through the Austrian Alps into northern Italy, probably using nuclear weapons at some stage. Number 2, explore FOBs, Fractional Orbital Bombardment System. And this we've already seen in 2021, where China's explored the technology, but it's not clear if they're going to weaponize it. Putting a warhead in orbit is very destabilizing. So the Americans could, for example, park a missile over China permanently and then just have it drop on top of China. So you could have geosynchronous satellites. They're not immediately on top of China. They'd be out into space at some distance. But satellites that are located 36,000 or 360,000 kilometers outside of the Earth, and these are distant surveillance and communication satellites, these systems are effectively immune even from anti-satellite systems because they're so far out. So you, in theory, could weaponize space and have these FOB systems that far out, and you can then bring them in at enormous speeds And and you can park them geosynchronously to threaten a country, and then you can give them a command to go back out into deep space. Number 3, overseas deployments, resulting perhaps in a Cuban Missile Crisis type of confrontation. So China might deploy nuclear weapons in countries that are sympathetic to it, like Venezuela, Cuba, Peru, Zimbabwe, South Africa, Iran, Pakistan. And China would use these nuclear deployments abroad to deter the U.S. from intervening against these states, in the same way that the Soviets deployed SS-4 and SS-5 missiles in Cuba as a part of Operation Anadir in the lead up to the October-November Cuban Missile Crisis. But they also deployed Luna rockets, which are the frogs, the free rocket over grounds. These were tactical nuclear weapons meant to destroy U.S. Marines if they had landed on the Cuban coast. And finally, 4, widespread tactical nuclear weapons deployment. China could follow the U.S. during the Cold War and deploy tactical nuclear weapons in the form of nuclear depth charges aboard ships, nuclear torpedoes aboard ships and submarines, nuclear anti-ship missiles like the Soviet Union deployed, nuclear bombs on aircraft, nuclear surface-to-air missiles like the U.S. did with Nike Hercules in West Germany, Italy, or ASROCs, which are nuclear weapons that are rocket-fired and drop a torpedo over a distant submarine, or air-to-air missiles like the nuclear Falcon or the nuclear Genie air-to-air missile. So China can certainly go in that direction. Now, the U.S. response during the latter stages of the Cold War, this is in the 1980s, was to focus on conducting one protracted nuclear warfighting. This was actually initiated by U.S. President Jimmy Carter in the late 1970s. He'd been responsible as a nuclear engineer in the U.S. Navy, and so this is a part of a significant escalation of how the U.S. is going to fight a nuclear war. Initially, the timeline was going to be essentially a nuclear exchange over several weeks. But Jimmy Carter, although he's very often associated with being someone who pursued peace, he recognized mechanically the importance of nuclear deterrence from the perspective of the Navy and came up with a plan for a very long-run nuclear war. That would contain the following elements. First, a focus on relocatable targets. In other words, mobile, train and truck mobile Soviet missiles that would be chased by drones, stealth bombers, deep penetration warheads, and quick launch high accuracy nuclear weapons from aircraft and submarines. So this was not a program from the 2000s or the 1990s or the Reagan administration, but the whole idea of autonomous drones and stealth bombers, all of that was conceived as technological solutions to destroy the Soviet second strike capability in the form of their mobile systems. The systems that we see today come from that technological initiative trying to solve that problem and are obviously repurposable for China's mobile systems as well. In terms of the high accuracy missiles, you could have a submarine at sea, which is normally not an accurate system, but the Americans developed technology where in just a matter of minutes, someone on the battlefield or flying over the Soviet Union could call in a strike, and a very accurate submarine-launched missile would take off, reorient itself according to the location of the stars, its own inertial system, and global positioning system, and then very accurately hit a high-speed Soviet vehicle moving along a road or on a rail system. Number 3, a disarming attack against ballistic missile submarines. In other words, locating and destroying submarines by detection from underground acoustic systems or satellites in orbit. Now, the Russian response to this type of problem was limited. They never quite came to a solution, and the Cold War ended without a viable technical response. Russia's nuclear doctrine today is very aggressive. The Russians have stated they will initiate nuclear weapons first and even engage in preemptive attacks if their state is under threat. So one could conceive of areas that the Russians think to be traditionally theirs, like a threat to Sevastopol, for example, as being sufficient for them to initiate a nuclear attack. Russia is undergoing demographic decline, compensated to a limited extent by immigration from Central Asia and other parts of the world. But it's put an emphasis on theater warfighting with nuclear weapons, for which it has a formidable capability because of the Russian experience of indefensible frontiers and repeated invasion from Central and Western Europe. Now, the biggest issue at the moment is the emergence of ballistic missile defense capability in the form of U.S. cruisers, Japanese, and British destroyers. The Americans have successfully conducted an exoatmospheric interception of a missile with an SM-3, a standard missile, from their warship. So the U.S. could deploy a warship off the coast of Taiwan or off the coast of China and intercept a large number of these ballistic missiles. The Japanese have developed this capability as well. It's now 10 years old, and so probably most of the Chinese warships now have this capability. And the sensor interception works even though the SM-3 missile may be much slower than the missile that it's launching to intercept. And this is without a nuclear warhead. This is with conventional fragmentation detonation. So the general assessment is that China is likely to be outclassed until at least 2030. And it'll have inferior nuclear forces until 2040. So this is almost 2 decades within which China won't have sufficient nuclear dominance to deter an escalation to nuclear weapons if a war broke out over Taiwan. So on one hand, the window of opportunity to attack Taiwan is closing. On the other hand, China does not have sufficient capability for almost the next 2 decades when it'll achieve parity. But even when achieving parity, the U.S. could still fight a limited war under nuclear conditions if they can demonstrate they have the balance of interest.